a thumbs up in the chat box if I'm audible.
The chat seems disabled.
Dear students, kindly wait for 5 more minutes for others to join. Thank you for your patience. Mr. Bhupendra, are we ready for the session?
Hi, ma'am. Yes, we are ready for the session.
Okay, we can start in 5 minutes. We can wait for
Yeah,
others.
sure, ma'am.
Okay, thank you.
Hello, I'm audible.
Yes, you're audible.
Yes, ma'am, you're audible.
Good morning, everyone. It's my pleasure to welcome you all this month SmartLearn section on behalf of ASAP Kerala. SmartLearn is our monthly initiative offering hands-on workshop on emerging technology. So far, we have reached over 10,000 learners with the sessions on blockchain, AI, ML, data analytics, and more. Today, we are excited to dive into generative AI in collaboration with 360DigiTMG. This cutting-edge tech powers tool like ChatGPT and enable all generative images, video, music, and more. We will get a practical overview of how it's works and where it is headed. I am pleased to introduce today's trainer, Mr. Bhupendra, data scientist at AiSPRY, with strong expertise in AI, ML, and data analytics. He is also a certified Tableau scientist and passionate mentor in the space. Please join me in welcoming Mr. Bhupendra. Stay engaged, ask questions, and enjoy the section. Thank you.
Sure. Thank you, ma'am. Hi, friends. Welcome to the session. We'll start the session. Right. Please, let's wait for 1 minute.
Ah,
So, hi, friends. Good morning. Am I audible? Please comment in the chat box if I'm audible.
yes, the chat box is disabled.
Okay, no worries. I'm audible, right?
Yeah, you're audible.
Okay, great. Okay, so it's disabled for some, but I can see some people commenting and some
Okay.
people having access to chat box. Okay, no worries, friends. In case you have questions, you can ask me questions. And for our friends watching this on YouTube live, you can post your questions on YouTube itself, right? In the comment section, I'll just be there. I'll come there. And of course, I'll be taking your questions too. So this is the session on generative AI. As we all know, generative AI and prompt engineering. So when we talk about generative AI, first of all, what is generative AI? The name itself suggests AI is artificial intelligence. And when we say generative AI, we talk about the class of artificial intelligence or portion of artificial intelligence that can generate something, right? So basically, whenever we talk about generative AI, it is basically a class of artificial intelligence that can create new content, right? Example of generative AI when we talk about, we all have seen ChatGPT, right? We all use ChatGPT. So when we talk about the example, of course, ChatGPT is a really good example, right? Now, when we talk about generative AI, it's not about only text. If you notice, initially when generative AI came into existence or ChatGPT came, it was just giving answer in text and only text, right? You used to comment something or you used to write something, you used to type something, and you used to get reply in the text form only. But later what happened? As in all progress was done, now you can upload image in generative AI, right? You can actually give your speech in generative AI, right? Speech option is there. You can get image from generative AI. So when we talk about generative AI here or ChatGPT, for example, here it's not about only text, it's about images too, right? It's about audio too. So all these content, doesn't matter what content you're talking about, text or speech or audio, for example, ChatGPT is able to do that. Similarly, there are other generative AI platforms or large language models which can easily do the same. Now, what are other platforms? For example, when we talk about text, we clearly
DeepSeek is there.
know we are hello. Yeah, DeepSeek is also there. Yes. When we talk about text, for example, there's ChatGPT, there's DeepSeek, etc. In the similar way, there is images we talk about. For example, when we talk about images, there's Dolly, right? Sorry, not DALL. There's Dolly, right? There's
Midjourney.
Midjourney, exactly. Midjourney, etc. Right? When we talk about music, there's something called jukebox that you can use. When we talk about video, a very famous is Runway, a very famous platform is Runway ML. Right? And of course, there is code, for example. When we talk about code, nowadays, if you are using Google Colab, you can clearly see whenever you're typing something, it will assist you in that. So yes, again, there's Code Whisperer. There is even in there's Copilot, for example, right? There's Copilot. Or in Colab also nowadays, we have that feature. It can also generate, it can also predict all those things. And of course, when we talk about voice or audio, we have 11 labs, right? So all these are very famous examples of this generative AI setup, not just based on text, but images, music, video, code, voice, all those things, right? So again, we'll be talking about the content, how this content is actually generated. When we talk about ChatGPT, how ChatGPT actually functions internally, right? From the very basic to the advanced level, right? We'll try to cover everything in this particular session. So talking about today's session, what is the agenda for today? Agenda is very simple. We'll talk about overview. Of course, we talk about the same. Second, we talk about is embeddings or basics of text mining. Is that really needed? Yes, of course, you need to understand what is chunking basically, or what is tokenization, what is embedding. All those things are really, really important to understand these things. Now, after text mining, of course, we'll talk about the journey from basic AI to generative AI, right? So we talk about the journey from RNN directly to transformer, from RNN directly to transformers. How this progress actually happened. And when we talk about transformers are the generative models we talk about. Along with transformers, we'll talk about autoencoders, We call it as VAEs or variational autoencoders. We'll be talking about GANs too. And when we are talking about this, we'll be talking about the diffusion models too that generate image data, right? Of course. And when we talk about transformer, we'll talk about the different models we have here in transformers. Once this part is done, we'll be talking about prompt engineering. Of course, in a very brief, but in a brief manner. But at the very same time, we'll talk about how to create a really good prompt, right? How to type a perfect prompt. We can talk about this. Also, when we're talking about this, we'll be talking about other generative AI models. Other generative AI models. For example, there is CLIP, right? There are diffusion models that we talk about. We'll be talking about them. Once we are done with this, we'll be talking about LangChain. There is RAG that we need to discuss. There's something called fine tuning that we can talk about too, right? And of course, ultimately, how to make a model and deploy it. We'll be talking about all these things in this session, right? So let's start with the session. So when we talk about traditional AI or artificial intelligence, or basically machine learning, we know most of you might be from machine learning branch or might be from CSE branch. You know, machine learning, when we talk about model learns from pattern, right? And model learns from the data that we give to the model. Next, after that comes AI. All this, of course, becomes part of AI, ultimately artificial intelligence. Machine learning leads to generative AI. Of course, machine learning, after that, there is RNN in artificial intelligence, basically neural network. When we talk about machine learning, we are not using neural network, but following machine learning, there is something called neural networks. Which is followed by, of course, there will be RNN. There, of course, in RNN, we'll make some progress and we'll move towards generative AI, right? In generative AI, what we see? We see large language models. Now, what are large language models, friends? Large language models are basically those models which are trained on large volume of data, right? For example, when we talk about ChatGPT, that is also trained on large amount of data, massive amount of data, right? In the similar way, we have Gemini, we have Grok, and all other such large language models. Now, in large language models, of course, we'll be talking about retrieval augmented generation 2, RAG we call it, a very famous technique, RAG, right? And along with this, we'll be talking about fine tuning too. So, to make this model, as a generative AI engineer, you'll make these models. And when we talk about deploying the same so that it is available for the user to use the application. For machine learning, we have MLOps. For generative AI, we talk about GenAIOps. LLM, we talk about LLMOps. And RAG, we talk about RAGOps. These are just towards the operations part. They just move towards the operations part or deployment part. Now, when we talk about this particular project or this particular session or generative AI, for example, 2016 was the time when transformers came into existence, right? And from there, it started booming like anything. Before, if you can see here, there's a clear demarcation between before transformer era and after transformer era or post transformer era. Now, we'll be discussing about this in detail. Don't worry about it. So when we talk about this language model, basically, first of all, we have models that have NLU or natural language understanding, which can understand the human language itself, right? Next comes NLP or natural language processing, where you started processing your natural language data, right? The same thing, the NLP we talk about, move further to large language models. And later we have massive multitask language understanding. Whenever we talk about a large language model, what do we do? Or whenever we talk about making a generative AI model using large language models, what do we do here? Here, first of all, when you have a training set, huge training data, you give the same, you train the model here, and you make the base large language model. Now, understand the base large language model has a lot of information, but it is not trained on complete data itself, right? For example, if you are owner of a company, it may happen that when the generative AI or the large language model was trained, it was not trained on data of your company. Now, if you want to make an application that will actually help others to understand what's happening in your company, so what will you do? Specific knowledge base related to your company, you'll give to the language model itself. And what will you get? You'll get a large language model that is pre-trained on huge data as well as specific to your needs. And this we call fine-tuned LLM. Most of the time when we talk about real-world data sets or when we talk about real-world application, we do fine-tuning to the models. Now, why is it needed? Because we want to use it for specific purpose itself. Now, while we are talking about large language models in generative AI, when we're talking about large language model in generative AI, here, large language models take a lot of space and the size is massive. So nowadays, there's something called SLMs2 into existence. These are small language models. These are small language models. Now, if you see the development of small language models, now understand one thing, the basic difference between large language model and small language model, it's just that small language model is of course trained on less data, large language model is trained on a huge data. Now, when we talk about a journey, right from 2019, we see there is GPT-2, and of course, there's OPT, there's Bloom, Galactica, and going further, if you see nowadays, we have PHI 3.5, right? There was PHI 2 in 2023. There are different such models or small language models. Okay. Now, whenever we proceed for in real world, whenever we talk about making a model, we understand one thing that is very important. That is DAR. DAR is decision analysis and resolution. We'll see why is it important. Decision analysis and resolution. Now, whenever we talk about this complete application, for example, while you are making application, when we talk about generative AI, you must be confused later whenever you are doing project. You might be having an issue in selecting a particular model, right? You want to select a particular model for your use, for your purpose, but at the very same time, you are not sure which large language model to use or which large language model to go for. For example, you can go for GPT, you can go for BERT, you can go for T5. These are different models. Now, each of them perform different applications, right? For example, based on your application, some are encoder only model, some are encoder decoder model, some are decoder only model. We'll be talking about this in detail. No worries about that. Now, for that, for a specific purpose, if you want to use anything, for example, when we talk about which large language model to use, right? In a similar way, there is something called vector database. Which vector database to use, right? For example, if you're doing annotation, which annotation tool to use? For all these things, DAR is very important. Now, what is DAR? DAR, as we discussed, is decision analysis and resolution. Now, whenever we talk about DAR, understand one thing, that for example, how to make DAR, we'll see. You have here features. For example, you talk about the different databases. Let's see which databases to use, which database to use when we are making a model, or which large language model to use. We can see. Let's see which large language model we should go for. For example, our aim or the project is about text summarization. Text summarization. Now there are different models. You know, there are different models available. For example, there's GPT, there's T5, there's BERT, there's BART. All these models are available. For example, there's T5, there's something called BART, there is something called BERT, there is something called GPT. Now, based on these models, we'll compare them on different features. And based on these features, for example, if it's encoder only model, if it's encoder decoder model, if it's, for example, text summarization when we talk about, right? So here we can go for which model we can clearly see. For example, we talk about feature, which feature we go for, like this. In this way, we can make decision analysis and resolution, and whichever model, for example, is the best one to go for text summarization, we'll choose that model and make our project on that particular model or using that particular model. So this is why DAR, or decision analysis and resolution, is very important. Right. Now there are different things. For example, which data layer to use, how to do data management, for labeling and annotation, which tool to use, for data pipeline and orchestration, which tool to use, for synthetic data generation, which tool will you use, for model layer, for fine tuning, which tool you will use, for RAG, what will you go for, right? In this case, for example, if there are different options we have, which is the perfect option for our project is what we'll see using DAR, right? Now, okay, these are some design considerations, again, about operationalization requirement regarding safety, data sources for production, right? For example, when we talk about large language models, which one will you go for? OpenAI, non-OpenAI, multilingual model, evaluation and testing. How will you evaluate and test the model? When we talk about architecture, we'll talk about chains. All these things we'll see in generative AI. We talk about agent. Are we going for single agent? Are we going for multiple agent? Right. Again, we talk about memory. What about context? Will that be long-term memory or short-term memory? Long-term memory will actually remember all these things for a longer period of time. For example, when we talk about ChatGPT has long-term memory, right? So again, we talk about safety. If there's bias in our model, if there's, for example, if the model is trained on the data that has hate speech or bias, is the model hallucinating? Hallucinating means when we are putting something on, we are inputting, giving some input. If the model is giving wrong answers or not a clear answer, if there is information loss, all these are different considerations when we actually make the generative AI model. a generative AI app for that matter. We'll talk about safety. When we have data, is there a chance of data leakage, right? If there's chance of model exploitation, if there is transparency or not. Generally, when we talk about AI, these are basically black box model. That means we don't know what is actually happening inside the model, how it's making decision. So that it lacks transparency. But whenever we talk about the same thing to the client needs transparency, right? So there is something called XAI nowadays that we are focusing on. XAI, that is explainable AI, right? To make sure that we are able to explain how the particular model is actually taking decisions, right? Again, we talk about data source integration. Are we using different APIs? For example, if we need weather data, are we using weather API? Are we connecting it to different databases? What database we are connecting to, right? Again, all these are design considerations whenever we are making an LLM application, large language model applications. Or when we talk about large language model application, we are basically talking about generative AI application itself, nothing else. Okay. Now, whenever we talk about the project in generative AI, of course, we'll be talking about each and every component in very much detail. If you see here, this is the complete process that we follow here in generative AI. For example, there are different data sources here. Data sources. Again, data source can be a Word document, can be a markdown file. There can be web pages, Wikipedia, blogs, video transcription, etc. Also, when we have this Word documents, what do we do? We break them down into small tokens or chunks. Once we break it down into small chunks, we go for embedding. Embedding, here we can use OpenAI, we can use Hugging Face and all those things, right? Now, once embedding is done, embedding is nothing but converting the tokens into high dimensional data. The same thing goes further and we store the same in a vector storage or vector database. What do we do? There are different vector databases or vector stores. For example, we have FAIS, Facebook AI semantic search. There's something called Pinecone, Chroma, VV8, Milverse, etc. We'll be talking about this also in very much detail, right? Again, when you are giving some input, it just embeds again. It is also embedded. And of course, we do vector search or similarity search we talk about using approximate nearest neighbor or cosine similarity, right? Now, whichever is the perfect one, we'll go for the matching chunks, whichever matches, we'll make the prompt, and using the large language model, we can get the answer. Now, all these things, friends, we will be dealing with. Throughout the session, I'll be coming back to this slide so that you are perfect with all these things. You are very clear with the flow that we follow in a particular project. Let's not forget, in generative AI, it's more about making the application. When we're talking about the session itself, it's more application based. We'll try to make sure we have limited time, but at the very same time, we'll try to make sure, even using ChatGPT, if we can make our own model, if we can make our own generative model, right? That will be really good. Again, if we have to do that, we'll make sure that we run a bit faster. Basically, whatever is important, that will cover, and we'll focus on, at the till the very end, we'll focus on making a model itself. And how to make a model, I'll be guiding you, right? Don't worry. Of course, I won't be coding it completely. In general, when we talk about making the model at AiSPRY, at 360DigiTMG, AiSPRY, basically, it's our AI consultancy fee model, AI consultancy company. When we make model there, we do a lot of stuff, right? We do a lot of things here. But at the very same time, for this session, since we have very less time, we'll be making model using ChatGPT. so that you understand what actually goes in and how easy it is to make generative AI models, right? Okay, we'll be using Hugging Face rather than OpenAI, which is again paid model. We'll go for Hugging Face. I'll show you how to make Hugging Face tokens and all those things, right? Now this thing will come back again. We'll come back to this thing again. Now there's very basic difference between AI and generative AI. Okay, before we proceed further, till this part, is there any question, team? If there's any question, for example, if you feel if there's any question, please feel free to post in the chat box. I'll be answering the same. And at the very same time, as we discussed, there is a YouTube live going on. Our friends are there on YouTube too, watching this, right? So friends, if you have any question, please feel free to post in the chat box itself, okay? And for you, I have one question or one more thing here, right? If you are staying for the whole time here, we'll be making sure that by the end of the session, we'll be taking attendance and we'll be giving you certification for the same, right? You'll be getting certification regarding the same. Okay. Okay, I see no questions, so it's fine. We'll proceed. Just give me a minute, team. And of course, if we see the timing, yeah, one thing I need to make sure that if it's 10:30, so by 11:30, we'll take one break for 10 minutes. After that, we'll take by 11:30, we'll take one break for 10 minutes. After that, at 1 p.m., we'll have a longer break, lunch break. That will be for 45 minutes. We'll come back and we'll continue from 2, basically from 2 we'll continue to 3:30, and from the 3:30 we'll have a 10 minutes break and then we'll continue till 4:30, right? So this will be the schedule today. Okay, you can see here the genesis of AI and generative AI. So when we talk about the genesis of AI and generative AI, here AI, when we talk about, again, there is Turing test by Alan Turing from 1950s, 1969, and then 1970 to 89. There's AI winter, not much development was done. Right, 1991 to 1999, there was Alice, a chatbot by Mr. Richard Wallace. And from 2000 to 2009, again, there is Roomba and Siri came into existence, right? Siri, we all have seen. We all know it's an iPhone, right? So from 2000 to 2009, there was Siri. And from 2011 to 19, if you see, there is a lot of development, right? From 2012, basically, the neural network came into existence, or neural network people started focusing on. When AlexNet came into existence, there were variational autoencoders, GANs, etc. And in 2016, we got Sophia, the robot, something that you might have heard about. And in here, transformer architecture came into existence 2016, 2017, right? And from here, the generative AI field actually took a leap. From in 2018, GPT-1 came into existence, 2019, GPT-2 came, and from 2020 to 2023, the world we are living in is actually getting shaped because of GPT-3, for example. There's GPT-4 nowadays, there's Bard, Llama, AutoGPT, right? All these things. 2022, there's ChatGPT, and all those things came into existence, friends. So this was the journey from 1950 to 2023. Of course, right now it's 2025, and there are other developments too. So when we talked about generative AI, of course, as we discussed, it can have image data or image applications. For example, text to image we talk about. We can use diffusion model here. right? We can use diffusion model, we can use clip models too. After that, there is video, text to video we can we can actually give text and we can get video in return. For example, in runway ML, if you see, you can do that. And text to image, for example, we clearly can talk about AiSPRY, VO3, yes. And when we talk about diffusion models, for example, text to image, you know, nowadays there was, recently there was a trend in Instagram, Ghibli image we used to make, right? Ghibli styled image. What we used to do, we used to give the image to ChatGPT and we used to say, okay, make a Ghibli style image, and it used to make Ghibli style image, and a lot of people posted it on Instagram, right? Of course, I believe most of you are in Instagram, and you all have seen that, right? Now, even if you are not in Instagram, you might have seen the same on YouTube, or might have heard about it, or might have read it in newspaper. So this Ghibli image was in trend few days ago, a few months ago, I should say. Okay. When we talk about audio, there is speech to text. You say something, it will be converted to text, or you give text, it will be converted to speech. For example, when we talk about speech to text, a very famous model is Whisper by OpenAI. And text to speech, a very famous model is again Tortoise, is there Tortoise TTS and 11 labs, right? So of course, sequence to sequence model we can use here. When we talk about text, we are talking about large language models. Large language models can be of three types. For example, they can be encoder or encoder only model. They can be decoder only model. They can be encoder decoder model. Again, when we talk about encoder model, there is BERT, Roberta, Distilbert. There are different types of encoder only model. When we talk about encoder decoder model, there's T5, BART, FLN T5, MTT5, ProfitNet. When we talk about decoder model, GPT-2, GPT-3, GPT-4, Llama. When we talk about Chat GPT, you might have seen it's using GPT 3.5, it uses GPT-4, using GPT-4o mini, all those things, right? These are different models, and these are some developments that are done. For example, if we talk about Chat GPT, if you're using Chat GPT Plus, for example, you can clearly see there are different models available. Any model you can use, it is fine-tuned for a specific purpose, or of course, a particular model will be better than other model for some specific purpose. So in this way, there is a lot of development done, and you can use, whenever you are using ChatGPT Plus, for example, you can use which model to go for getting the answer. And of course, we'll be coming back to this again, autoencoders and all. There are different timelines of models. For example, there are encoder only models. For example, BERT and all we talk about, there are the different model, encoder decoder model, and there are decoder only model. So when we talk about, actually, for example, in Chat GPT, or for example, DeepSeek, when we are talking about, which type of models are these, friends? These are basically decoder model or decoder only models. GPT we are talking about, BART we are talking about, Llama, for example, right? Llama by Facebook, GPT by OpenAI, right? All these things are example of decoder only model. We'll be coming to this. Before we go further, let's talk about the basic of prompt engineering. Yes, Namita, we're talking about specific algorithm like in ML. We don't have such specific algorithm per se. Of course, we have a basic flow, but there is no specific algorithm that is there. For example, we can use decoder only model for that. Of course, it is made in different way. There is different algorithm for that. But when you talk about specific algorithm like linear regression, we talk about or anything like that, nothing like that is there. We have models specifically for each purpose. Right? We'll be talking about that. Okay. Now, let's see the basic. Now, if you want to understand a complete process itself, for example, when we talked about this, you might be thinking, what are each and every step we are talking about? For example, what is this chunking? What is this embedding? What is this vector store? Right? What happens actually in vector store? What is semantic search? What is similarity search? We'll be talking about all these things, friends, now. Right? And that was right now, whatever we saw, that was just an overview of what we have in generative AI. Right. Now, of course, ChatGPT you already know. So rather than investing time there, let's just go further and move further towards the complete process itself. Okay. So till this part, is there any question, team? Because now we are moving towards text mining part. Very basic for you to understand what is tokenization, what is embedding, why do we do tokenization, why do we do embedding, all those things. What is basically vectorizations, all these things we'll talk about. Okay. Okay, let me see if our friends in YouTube have any question. And of course, you can come to our YouTube channel and subscribe to the same, and you'll find a lot of things here. You just come to our YouTube channel, and you'll see that there are a lot of interviews, a lot of courses for free. Come and explore it. Okay, I can see. Okay, I don't see any question here. GPT-4o. Okay. Okay, I don't see any question here. No worries, friends. If you have any question, our friends, our friends are watching this on YouTube. If you have any question, just feel free to ask. I'm here to answer your questions. Okay. Okay. Now, there is a certain process that we follow whenever we talk about generative AI. So what happens inside generative AI? How come ChatGPT is able to answer everything perfectly? Did you ever wonder whenever you type something in ChatGPT, it will give a lot of related information. How does it come up with this information? What happens in the background actually? These things we'll be talking about, friends, now. Okay. So, first of all, whenever we talk about the complete process, understand there is one term called document. In text mining, basically, there is something called document, and document is nothing but basically each and every line of sentence, you can say. Or for example, specifically if you're talking about consider you're talking about reviews of iPhone. Let me take you there. There are different terms that we generally see. For example, if I take iPhone 16 review, iPhone 16 Pro Max, it's review, for example. Now, see this. When we talk about reviews, consider that you have to make use of this particular review for your analysis. So if you see this complete information here will be one document for us. This will be one document. In the similar way, the another comment, if you see here, this will be another document. Right. In a similar way, as we go further, here we have another document. Basically, each and every comment, if you see here, is one document for us. Now, all these documents will combine together to form something called corpus. Right. So, when we talk about documents, so summation of documents, when you add all the documents, it becomes what? It becomes corpus. And this corpus is nothing but the data that we have to use for our purpose. For example, when we talk about NLP, if you have to do, for example, different applications, if you have to use this text data. So in the similar way, we can use each and every document here or corpus. Now consider you have made the corpus of the data. You have the corpus, and this corpus is nothing but your data. What is this corpus basically? Text data we are talking about, right? So text data. The first step that we do whenever we have this corpus or this text data is we go for the process called tokenization. Write it, friends, it's very important. Tokenization. Now, what is tokenization? Tokenization is a process of breaking the large data into small tokens or small chunks. Tokenization is a process of breaking large chunks, large document or large text into smaller tokens. Now the question would be, what are these tokens? These tokens are nothing but small constituents of a large sentence. It may be a character, it may be a word, it may be a sentence, depending on your application. So when we talk about token, these are small constituents or small constituents of a sentence. When we talk about tokens, it can be a character, a word, or a sentence. It can be a word, it can be a character, or it can be a sentence. Okay. Now, right now, which process we are talking about? You must be wondering what process we are talking about right now. So if you see here, there's something called chunking, right? Chunking, basically breaking this data into smaller chunks. We are talking about this process. Okay, let's go back here. Now, tokenization, as we discussed, the process of breaking large file into smaller tokens. Let me just clear this, and I'll explain the tokenization part we have here. That is very important for you to understand, friends, because tokens, embeddings, these are the words that you'll see continuously. Okay. Now, tokenization. When we talk about tokenization, there is character tokenization, there is word tokenization, there is sentence tokenization, there's something called n-gram tokenization or n-gram. When we talk about n-gram, it is basically unigram, bigram tokenization, and trigram tokenization. let's see what we are talking about. Now, this is very, very basic that you actually need to understand what is similarity search, what happens in vector stores, how a model is able to give the related data. This is what is a basic for that. Now, when we talk about tokenization here, let's talk about character tokenization. Consider there is a sentence. This is a session on generative AI. If this is a sentence. Now see here, and it is on 28/06/2025. Now see this. If you see, there are two sentences. If you understand one thing here, there are two different sentences. This is one sentence and this is another sentence. This is one sentence and this is another sentence. If we have to do tokenization, if we have to do sentence tokenization, this particular one sentence still full stop will become one token. Basically, this will be one token. This will be another token. This will be second token. In the similar way, this is basically sentence tokenization, where you are taking a sentence itself as the smallest unit. Now, let's go towards the next part, that is character tokenization. Sentence tokenization, you took a complete sentence. When we talk about character tokenization, you are taking each and every character as a token here. Each and every character will be one token. So this is character tokenization. For example, this token T, this character T is one token, H is one token, I is one token, S is one token. This is character tokenization. Let's move towards the next part, that is word tokenization. Now, word tokenization is generally what we use. Sorry. Let's move to the next part, that is word tokenization. Now, in sentence tokenization, we saw a complete sentence. Here, in word tokenization, the very important part of tokenization, word tokenization, we take each word as a token. This is a session on generative AI, right? It is on this date. Each and everything will be a token. Each and every word will be a token. This is called word tokenization. Now, let's move towards forms of word tokenization. For example, when we talk about n-gram, there is unigram tokenization, there is bigram tokenization, and trigram tokenization. When we talk about unigram tokenization, let me write this sentence in a one line itself. That would be better. Okay. For example, if I write a sentence, Virat Kohli is a really good batsman. Okay, fine. Now, in this, when we are saying Virat Kohli is a really good batsman, we are saying for each and every word, we are saying we are doing word tokenization, right? You see, word tokenization means each word will become a single token. In the similar way, when we talk about unigram tokenization, it is similar to word tokenization. Each and every word will become one token. When we talk about bigram tokenization, friends, two words will become one token. For example, for bigram tokenization, Virat Kohli is one token. Kohli is a one token. Is a another token. A really another token. Really good another token. And good batsman is another token. So here, when we're talking about bigram, this means here each word is a token, unigram. Each word is a token. When we are talking about bigram, two words become one token. Now I have a question. It feels Joseph's question. No, Joseph, we are not taking spaces here. When we are talking about this, right? So space, if we're talking about this, so space could also become a token, then that would be a problem. It doesn't add to our similarity search or any, for example, any analysis. Okay, so we are taking these two words as a token itself. Yes, Farheen, when we are talking about tokenization, when we're talking about bigram tokenization, we'll take two words as one token. But see, for understanding of our model, for model to should understand that Virat is related to Kohli, and here in this Kohli is related to is, if you want to form a sentence. And that's the reason Virat Kohli is a one token, Kohli is another token, is a another token, a really good batsman. In this we are sliding, in this we are going further, so that it is easier for the model to understand. Okay, I hope it's clear, Fareen, and it's clear. I hope it's clear, Joseph. Okay. Okay, Fareen. Okay, Joseph. Great. Now let's move further to the third part, that is trigram. When we are talking about trigram, the way we have seen bigram, we'll be talking about trigram too. Trigram is again three words together form one token. Virat Kohli is a really good batsman. In this way, three tokens together, three words together will form one token like this. Right? Three words together are forming one token. So this is unigram, bigram, trigram. Now understand one thing. What's the difference between which one is better, unigram or trigram? Now that depends on our requirement, friends. For example, when we talk about unigram to trigram, when we move from unigram to trigram, two things happen. One advantage is context becomes clear. When we talk about context becomes clearer, I should say, becomes clear, or that would be fine. And when we talk about second point, this is advantage of it, and this is disadvantage of it, that computational power increases. Computational power increases, or computational resources resource requirement increases. Now, what is this? Context becomes clearer. Now, answer me, friends, if I say the word hazard. For example, I have done unigram tokenization, right? I'm going for unigram tokenization, and if I say the word hazard, what do you think? It's a positive word or a negative word?
Negative.
Negative word.
Okay, it's a negative word. Fine. So when we are talking about hazard, we know it's a negative word. And again, this is unigram. When we talk about safety hazard, what do you think? It's a negative word or positive word? If we are talking about bigram. Safety hazard, see, still safety hazard we have, right?
Yes.
Yeah, again, it would
It's
be
a
negative,
difference.
right? So safety hazard, it's a negative word. Okay, negative. Exactly. Exactly, guys. Exactly, Farin. Safety hazard. But when you use now in a sentence, for example, it's written there is no safety hazard. Now it's very clear if there is no safety hazard, it's positive. But when we saw only one word that is hazard or only safety hazard, here we had that issue that the context was not clear because we didn't have more words. Another example I'll give. For example, if I say the word pretty, if I were say the word pretty, what do you think? Is it a positive word or negative word?
Positive.
Positive.
Positive word, right? But what if I say the word pretty is positive, but again, there's another word, ugly. Now suddenly it becomes negative, right?
Yes.
Yeah. So you can see I was trapped in a pretty ugly situation. So you are not saying that the situation was good. You are saying that the situation was really, really bad. So that was a pretty ugly situation. So in this way, when we talk about this thing, unigram to bigram to trigram, the context becomes clearer, right? I hope tokenization is very, very clear now. What is tokenization and all those things? Now we'll move towards the next part, that is vectorization. Now, once the tokenization is done, you understood tokenization very, very clearly. So we'll move towards next part, that is vectorization. Now we all understand when we talk about machine or when we talk about system, it understands word, or it doesn't understand words, it understands numbers, right? So when we talk about vectorization, vectorization is nothing but a process of converting tokens into high dimensional vectors. We'll be talking about it. Vectorization is nothing but process of converting high dimensional vectors, sorry, tokens to high dimensional vectors, my mistake, friends. Process of converting tokens to high dimensional vectors. Right. Now, what are these high dimensional vectors? How do we come up with high dimensional vectors? We'll see all these things. Don't worry. I'm here for you. We're here for you. We'll see all these things. Okay, I'm just clearing this thing now here from here. Now, when we talk about vectorization, there are different types of vectorization. Basically, we just want to convert a token, for example, a single word, into a number, a numerical form. Okay, fine. Let's move. Now, here it can be there is one form, one way you call one-hot encoding. One way of vectorization is one-hot encoding, or there's another way of vectorization called embedding. Now, this is what we focus on a lot. Now, why not one-hot encoding? Why embedding? Now, see this. One-hot encoding, if you know machine learning, one-hot encoding, again, I'll need to go in that much detail. One-hot encoding is really, really useful, but at the very same time, it generates sparse metrics. Right, I'll explain one-hot encoding too, but our focus, since we have limited time, is more on embedding. So for now, just understand that one-hot encoding is also a method of vectorization, but it creates sparse metrics, right? We'll see what happens in embedding and how do we have a high dimensional data, or how do we come up with high dimensional vector? This is what we'll focus on. Okay. So when we talk about embedding, we can use a pre-built model, or we can make our own model for embedding, or we can use a pre-built model. For example, there is something called Word2Vec, a very famous model called Word2Vec. There is, for example, CBOW in Word2Vec, that is called continuous bag of word, continuous bag of words. And there is something called skipgram. Now there is something called GLOVE2, that is by Google, global vectors. There's something called skipgram. I'll just Google it for you so that it becomes clear. Word2Vec, there is CBOW, there is skipgram, there is glove. All these things are embedding models, right? Let me just Google it for you. I hope you've written all these things. I'll be clearing this now. So first, data we have, data from data we convert into tokens by the process called tokenization. Tokenization, we convert from tokenization, we get tokens. We convert that into vectors in the process called vectorization, which is the most important process here. Right now, when we are talking about generative AI, we really need to focus on one thing called embedding, because embedding is what you'll see. Embedding, you can make your own model too, but at the very same time, a very famous model is Word2Vec and continuous bag of word and skipgram. There's something called glove, all those things. CBOW is continuous bag of words. Okay, now I'll clear this. Let me just go online and show you different embedding models. For example, if we just Google, for example, here we have Word2Vec. Once this session is over, feel free to go and actually search for all these things, friends. It is really good for your understanding word embedding, and we'll see what is semantic relationship, right? We'll talk about all these things. How do we come up with this complete words? So for example, to use this neural network, and for this I'll need to explain neural network too, but I'll refrain from that part, but I'll explain what is another important thing. There's continuous bag of word. For its architecture, you need to understand neural network. There's something called skipgram, right? We talked about this. There's something called glove too, glove. No, not this glove, glove NLP. So global vector for word representation, a very famous model here. GLOVE is an unsupervised learning algorithm for obtaining vector representations for words. Now I hope it's very clear. Vector representation, we need to convert the token or each and every word into vector or high dimensional vector. Now we can talk about Word2Vec and all, but rather than going for that, I'll talk about the the embedding intuition, right? Okay. First thing, whenever yes, understand one thing, there is one hot encoding and embedding. We can go for one hot encoding too, but one hot encoding is a sparse matrix, or it gives, for one hot encoding you can write, it gives sparse matrix. Now, due to this paucity of time, I can't explain you what is sparse matrix and all those things. I can go in detail, but again, that will finish our time very fast. That will take a lot of time too. So embedding, we get dense representation. Dense representation. Dense representation, basically, there won't be a lot of sparse matrix. Sparse matrix, again, there are a lot of zeros when we talk about in a matrix. It gives dense representation. Now, how does it give dense representation? This is what we'll see. We'll see the intuition behind the embedding. let's talk about another part. Okay, till this part is everything clear, team? I'll go to YouTube and see if there's any question from our friends in YouTube. Okay, clear, right? Okay, Alexander. See, it's very, very clear that we need to understand whatever we are understanding, the concept should be very clear. And if you have this basic, you can make Harsha, it's on YouTube itself, so you can assess. You can come here and you can assess this anytime. Yes, Koman, don't worry, you'll be getting certificate. If you are here till the end, you'll be getting certification for this. No, Anthony, we are not ignoring YouTube messages. If there's any question, I am coming back to YouTube. Don't worry about that. Okay. Okay, tokens similar to keywords. Can you please clear this? Tokens and keywords, when we are talking about keywords, are specific words only, right? When we are talking about tokens, each and every word will be taken as a token. Okay. Harsha, no, space is not taken as a token. Is there any AI for create video means photo to video? Again, you can combine. You can try Runway ML. That would be really good. Keyword is a token in itself, yes. But when we talk about keywords, again, we don't only take keywords as tokens. For example, if you want to take that, again, we need to remove stop words too. In that case, we are taking only very important words or stem words as token then. Okay. Okay, guys. Now, yes, guys, we'll get certificate here. Don't worry. Yes, Helena, you'll be getting certificate here. Okay, don't worry about that. I'm here. It's just that I was explaining the concept. Yes, RG creations, when we talk about this, what happens? It depends on our application. We can go for sentence tokenization too. We can go for example, again, word tokenization too. We can word tokenization, that to unigram tokenization. We can go for bigram or trigram. That specifically is related to our application. Okay, whenever we need that type of application, we can get that here. Okay, Nagaraju, now vectorization is nothing but just a way of converting vector into token. Guys, if you have no question, I please request you to mute yourself. Right. No, Harsha, there is no specific size of corpus per se. We have data, more the data, better the model will be. Right. Yes, DT80, it will be available. Okay. I guess we have taken a lot of questions already. Okay, now let's get back and talk about the intuition behind how to mark attention. Dilsha, you are already, if you are here, we can clearly see you that you are here and we can take that as an attendance here. Just be there by the end of the session. We'll be taking attendance and whoever is attending the session will be getting certification for the same. Okay. Now, guys, please mute yourself if you have no question. Okay. Okay, fine. Let's go, friends. Let's move further and understand what are these high dimensional vectors. Now, okay. Consider I'm talking about different person. For example, if I say I'm talking about man, I'm talking about woman, I'm talking about king, I'm talking about queen. I'm just talking right now, we are talking about the intuition behind embedding. How do we get high dimensional vectors? Right. Now, how do we get dense vectors? And how do the same thing, if you understand this, it will be easier for you to understand similarity search. Okay. Now, when we talk about these features, for example, man, again, there will be different features we'll be training our models on. Sometimes a model may have Our embedding model may have some 300 features using which it is training the complete data. Basically, here if we see, for example, man, and we'll just write has mustache. One feature will be has mustache, right? So has long hair, right? And has crown, if it's a royalty or not. If it's for example, has mustache, long hair, crown. Come on, team, try suggesting me a few more things. For example, if we talk about man, has shorter hair, has long hair, or has shorter hair, and again,
Well dressed.
well dressed, yes. Commoner or not? Okay, yes. Commoner or not commoner?
Yes.
Yes, and well dressed. Yes, and in such way, consider there are some 300 features, right? When we talk about it, for example, why am I coming up with these features? For example, okay, let me just come back to this. When we talk about embedding, trained on number of features. Now, for example, here when we talk about how do we do how embeddings are trained, exposing our model to large amount of text data and adjusting the vector representation based on the context in which word appear, right? So all these compared context feature embedding, training a model to predict a category given in context. So how do we come up with the context itself? We come up with these type of things. So for example, now understand if we talk about mustache, what do you think? A man has mustache? So yes, some men have mustache, some men may not have mustache, right? So again, I'll say 0.7 out of 1 I'm saying, or out of 1 I'm saying. For example, I'm considering -1 to 1, right? Is the range I'm considering, just for your understanding. Has mustache, a man has mustache, yes. Woman has mustache, again, chances are very less, right? So we are saying -0.7, right? Again, some women may have a bit of mustache, but again, I'm not saying that every woman has that, may have because of some hormonal imbalance, but again, they will be women too. So again, I'm taking it -0.7. When we're talking about king, has mustache? Yes, he has mustache. Most of the time when we see kings, they have mustache. So mustache and beard and all those things. So I'll say 0.9. Right, now it's very much similar.
Yes.
And when we talk about queen, again -0.7, because queens don't have mustache. Again, I should keep it as -0.9 because queens generally don't have that. This is what we know. Long hair, man generally don't have long hair. They have long hair, but again, chances are of having long hair is less. So for example, -0.5. Women generally have long hair, so 0.9. King may have, may not have. So I'll say 0 or 0.1. I'll say queen again has long hair, 0.9. Again, or I should, for example, if I just say, okay, king is a man too. So I'll just say, okay, -0.5. I'll just make him -0.52. Has crown, again, man doesn't have crown, right? Or I should say it has
-1.
-1, right? So woman doesn't have a crown. King has crown. Yes, he has a crown. Woman has a crown. Queen has a crown. Royalty? No, a man is not a royalty. Woman is not a royalty. King, definitely a royalty. Queen, definitely a royalty. Or you can make it -1 too. Has shorter hair? Men, yes, has shorter hair. So I'll just say, okay, 0.8. Yeah, 0.7, I'll say. Some men have shorter hair. Or 0.9, I should say. Right? Women, -0.9. They might not be having it. Or 0.5, I'll take. King, 0.9. Or 0.9, or again 0.8, 0.7 I'll make. Queen, 0.9. sorry, minus 0.9, they generally don't have shorter hair. Commoner, 0, yes, okay, they are commoner, right? So the commoner, yes, they are commoner, they are commoner. King is not a commoner, so it's minus 1, minus 1. Well dressed, they may be well dressed, so 0.1, 0.1. King, definitely well dressed. In this way, what are we doing here? We are just converting a particular token. For example, if this is a token, we are converting this as in this way. For example, there are some 300 such features. What are we doing? We are converting this man word into some 300 features, right? And for example, I'll just say on we can get them on tree. No, fruits we can get on tree. So in this way, each and every word we are trained on such 300 or 400 type of embeddings here, right? I mean, these 300 or 400 type of features like this. So notice one thing. What are we doing? When are we embedding? We are converting them in a very dense matrix, a dense vector. So if you see high dimensional, when I say embedding is nothing but converting vector into high dimensional vectors. High dimensional. Why high dimensional? Because there are some 300 some features. So this is very high dimension. So high dimensional vectors. What are these? These are nothing but vectors, right? Has magnitude as well as direction. So these are vectors. So high dimensional vectors. So this is how we come up with embedding. For example, now after this session, feel free to just Google, okay? For example, when we talk about embedding, if I just say images, for example, there might be some or the other document that might be given as images. In this way, for example, here, yes, here the same example is given. Man, woman, king, queen, living being, feline, human, gender, royalty, verb, plural. In this way, lot of things are given, right? Now, notice one thing here. In that case, if we see a king is a man too, right? So if we see in dimensionals, for example, in 2-dimension, if we see here, or I'll just make it something like this, 2-dimension, we can say man and a king are nearby. In the similar way, queen or a woman and a queen are near to each other, right? So man and a king are near to each other. King is a man too, but a bit of difference is there, right? And queen is a woman, but a bit of difference is there. Now, these are similar. When we talk about this, these are very much similar because the difference between them is very less. Man and king, these are similar or closer to each other. A king is closer to man as compared to queen or as compared to woman. A man is closer to a king, the word man is closer to king than the word woman, right? So this is how we actually see. And similar thing happens in similarity search. Okay, so we'll talk about the same too. Let's just go here. Okay. So now if we see here, what is happening? We talked about the corpus or the data source. We talked about chunking. Chunking is nothing but tokenization, converting words into tokens. And here we move further and we see what do? We do embedding. Here, just a minute, friends. That's okay. We do embedding. Embedding what? Here we can use Hugging Face. We can use OpenAI. we can use word2vec, we can use glove, we can use fast text. All those things we use to do embedding completely. So corpus is clear, chunking is done, or tokenization is done, and after that we do what? We do embedding. Through embedding, we convert that into high dimensional vector. Right. Now, once we are converted, now we'll see the till vector store we'll see, or for example, till all these portion till vector store and what happens in vector store till this part we'll see, and after that we'll move to RN and its journey, large language models we need to see, right? Okay. Now understand one thing. Okay, we'll do one thing. We'll take break for 10 minutes. We'll come back. It's a very intense session, right? We'll come back 10 minutes, friends. Just go and freshen up yourself. Come back, and yes, we'll start with the vector databases. What happens in vector databases? What is similarity search? There are a lot of topics to cover, friends. Don't go anywhere. Come back. We'll see that. Okay. Let's take break for 10 minutes. Okay, till now, is there any question before we take break? Is there any question, friends? I hope everything is getting clear. Is it clear for you? The process that we are following, basically, I hope it's clear for you. Okay, great. Okay, Fareen. Okay, what about others, friends? Is it clear?
It's clear.
Let's talk.
Yes, sir.
Oh, okay, Madhu.
Yes, sir.
Okay, Alexander. Let's talk about YouTube. Let's talk about if we have any questions on YouTube. Please, no breaks here. Right. Let me take questions. Okay. High dimensional vectorization. Shivam, we just discussed what is high dimensional vectorization, right? So what are high dimensional vectors? Because of lot of features, we are training each and every word on such features, and that's the reason the vector we are getting is of very high dimensional. For example, if we are using 300 plus dimensions or 300 plus features to train, depending on number of features, we have dimensions. So high dimensional in this way. What if prompt doesn't follow grammar? How the tokenization happens? Zia will be talking about it. Don't worry about that. Tokenization happens, doesn't matter. See, now, right now I'm considering, just to give you an example, I've taken those words too. In reality, in real life, those words are removed as a stop word, right? We won't take tokens. We'll be talking about it, right? What if prompt doesn't follow grammar? For example, in ChatGPT, even if we are not following grammar, still we are learning that. Still it is giving the answer, right? We'll be talking about it. What about attendance? Attendance will be marked. Don't worry. Is one by one magical direction. Attendance will be marked. Oh, you guys can do one thing. If you are not able to attend the same thing in session, you can just write your name in the chat box itself. So it will be easier for us. For example, one magical direction, we won't understand your name, right? So what you can do, just put your name here so that we can understand that you were here and we can issue certificate for you too. Okay, just put your name here, complete name, that will be fine in YouTube or in the comment section of this Zoom link. For generating tokens, will make the word to its base form. Yes, Saiteja, for example, when we talk about tokens, we convert it to base form, that is called stemming, right? But here I'm not going that deep in text mining part, right? That is the sole reason. I'm just giving an overview of what happens. We don't have actually enough time to deal with each and every part. That is the one disadvantage. Okay. What negative and positive number represent? So Shivam, for example, when we talk about positive numbers, it is towards the male. For example, negative numbers, it's towards the female. Basically, just opposite to that. For example, if we talk about gender, male is one gender, that is towards one part, and female is another gender, so that is on the negative part. Or if female is on the positive part, male would be on the negative part. So this makes them are different completely. Okay, they are in complete different way. Okay, what's the difference between 0 and -1? Both mean the same. Harish, 0 we are saying just a bit neutral, -1 extreme negative, +1 extreme positive. For example, if I'm saying I'm a man, so it may be 1. If there is someone who's woman, that may be -1. We are complete opposite poles. We are not talking about 0 and 1 here. We are talking about -1 and 1 here. -1 and 1. So two different dimensions. Yes, Arya Mary, you'll get it. As I mentioned, just mention your name here. That would be really good. Okay, I can see not name. Okay. Vectorization, Brahma, for example, when we talk about vectorization, is nothing but just a process of converting tokens into vectors or high dimensional vectors or numerical values, basically. Context of the word, Kevin, based on this itself, based on their embedding, the context would be determined. We'll talk about similarity search, then it will be clearer. Okay, friends, let's go for a break. Let's go for 10 minutes of break. We'll come back and then we'll continue. Okay, guys. Okay, friends, I hope you people are back. Let's continue with the discussion. Okay, so I have 4 questions or so. Okay. Okay, you guys are just writing your names, right? Fine. That will be fine too. Okay. Now, till now, we know we have, for example, data or chunk, data or corpus. What do? We do tokenization. And after tokenization, we are doing vectorization. In vectorization, we have seen one-hot encoding, and there is something called embedding. Embedding is what we are focusing on. Embedding generally converts into words into high-dimensional vectors. Okay, fine. Now, embedding, of course, is about 2-vec and all those things, fast text and all those things, but fine. High-dimensional vectors. And now, after this, we have seen the intuition. We have seen the intuition behind the high-dimensional vectors. Okay, fine. Now, one thing is very, very clear that you have got some numerical values. This means you have got some vectors which look like minus 0.8, 0.76, and 0.6, for example, 7.2, or anything like this. So basically, we are talking about numbers now. Okay. Now, what happens? There is something called databases, or there is something called vector databases. Now, we'll be dealing with similarity search, but before that, let's talk about vector databases. Now, when we talk about vector databases, there are different vector databases. Vector databases are the databases which store high-dimensional vectors. Store high-dimensional vectors. This just means after data tokenization is done, of course, there is stemming and everything, all those steps. When we get tokens, tokenization is done, we do embedding, and once embedding is done, where are these embedded data saved, or where are these high dimensional vectors saved? These are stored in or saved in vector databases or vector stores. Vector databases or vector stores. Here. Now, there are different type of vector databases. Now, what are vector databases and how are they different than the databases that we have seen till now? For example, let's talk about the basic difference between traditional database and vector database. When we talk about the traditional database, we all have seen one thing, that is MySQL, for example. Traditional database, I am talking about RDBMS or Relational Database Management System. And there is another one, that is vector database. Okay. For example, you can talk about different vector databases. We have FAISS, that is Facebook AI Similarity Search. That is, there is Chroma, there's something called VV8, there's something called Redis, there's something called Melvus, there's something called Pinecone. Right? All these are vector databases. Now, there are many. Such vector databases we use to store high-dimensional vectors. And now we are talking about traditional databases and vector databases. Now, traditional data, when we talk about vector databases, it stores high-dimensional vectors. Traditional databases or RDBMS, for example, doesn't store higher dimensional vectors. It stores data in the structured form. Structured data it stores, and here it stores what? It stores vectors or high dimensional vectors. Now, why we can't store the same thing in traditional databases? Because traditional databases are not made in that way. Very simple. Now, when we are talking about vector databases, what happens here? When we are searching for some information in structured database or RDBMS, for example, we are using what? We are using SQL. And what do? We write query to get the perfect answer. Here, the focus on in the traditional database or in the structured database, for example, or SQL, for example, is searching for the perfect answer. Perfect answer based on the data. But here in vector, we are not talking about the perfect answer. We are focusing on similarity search. We focus on similarity search. Now, what is similarity search? We'll be talking about it. Okay, so for similarity search, you need to understand what are vectors or what is vector databases. So similarity search happens inside the vector databases. Okay, fine. Let's move further. Let me clear this. Okay, now when we are talking about this and what happens in vector databases, similarity search. Now please write it accordingly. Similarity search happens in vector databases. Now, how we understand the context and all these things? We talk about the similarity only, word similarity only. Now, when we are talking about similarity search, one particular thing that you have studied before, that is cosine similarity. Cosine similarity. If you are from machine learning, you might have seen this cosine similarity. You might have heard about this cosine similarity. What do? Using cosine similarity, we do similarity search. Again, there is something called ANN, approximate nearest neighbor. We'll talk about it too, right? So similarity search, we say, we search for, or this is used to measure how similar two vectors are. We measure how similar two vectors are, of course, regardless of their magnitude. It doesn't matter how much magnitude they have. We just want to say, we want to calculate how similar vectors are. We just focus on calculating the angle itself. Now, cosine similarity generally varies from 0 to 1. Okay, cosine similarity varies from 0 to 1. We say more is a cosine similarity if cosine similarity we say higher, we say the words are similar or the vectors are similar. Vectors are similar and lower vectors are different. Simple, right? When we talk about cosine similarity, when we say it's lower, vectors are different. Okay, now this is what we generally use. At the very same time, there is something else. There is one more thing called distance measurement. Now, if there are two vectors, here is this question. Vector, Aishwarya, we were discussing about vector itself. When we talk about vectors, these are nothing but numbers, for example, numerical values for the tokens itself, right? Vector databases store what? Stores high dimensional vectors. High dimensional vectors, how do we get high dimensional vectors? Before this, we talked about the intuition itself, right? Intuition of high dimensional vector. How do we come up with high dimensional vectors? That is trained on number of features. More the number of features, more is the dimension of a particular vector. Okay, I hope it's clear, Aishwarya. Okay, now vectors are similar, vectors are different. If vectors are similar, this just means that the word itself, the token itself, is similar to another token. This means here, whenever we talk about cosine similarity, understand one thing very, very clearly. We are talking about another word called distance. Cosine similarity, more is the similarity, lesser is the angle. Okay. Now, for example, here, what are we focusing on? In terms of graph, if I'll explain, if in terms of diagram, if I explain, this is king and this is man that we were discussing. In that case, we say there is this line goes for king, this line goes for man, right? We say the distance here, the angle is less. When we say angle is less, we say there is very high similarity. There is very high cosine similarity, right? In the similar way, if you notice, also when we say less is the angle between them, more or less is the similarity, more is the cosine similarity, right? So here, less angle, more similarity. Less is the angle, more is the similarity. In the similar way, there's one more concept. Okay, let me just clear it from here. I'll write it here. There's one more concept called Euclidean distance. Now, to find out how similar two things are, there's one more thing, Euclidean distance. When we talk about distance, lesser is the distance, more is the similarity. So lesser is the distance, more is the similarity. Euclidean distance is another metric that is used to calculate, to see how similar two things are. For example, when we talk about distance, you can just say it's 1 minus cosine similarity. This just means more is the cosine similarity, lesser is the distance, and when we say more is the cosine similarity, lesser is the distance, and similar two words are. Okay. Now, if I have to explain how similar two words are, I'll just deal with one thing. I'll just give you an example of cosine similarity itself. We'll take you directly to one. It will be easier for you to understand directly. You might have seen this, the same thing in recommendation engine, similarity measure generally. Now see this. Focus here. If we say, we talk about cosine similarity, we say cosine similarity is nothing but the angle, or here formula for it is A into B divided by mod of A multiplied by mod of B. This is just an example of how to calculate cosine similarity. Now consider there is one word. There is one word, man. There's another word, king. I'm just giving an example, nothing else. Okay, I'm just giving an example for you to understand how this cosine similarity works. Now, the man has some dimensions or has some vectors. The vector here for man is 3, 5, 4, 1 like this. The vector for king is 1, 4, 4, 2 like this. Now we have to find the cosine similarity. How do we calculate cosine similarity? Here, the formula here goes A into B. When we write, it would be A1 into B1 like this, A1 into B1 plus A2 into B2 plus A3 into B3 plus A4 into B4. Okay, divided by the same thing, divided by mod of A, that is A1 square plus A2 square plus A3 square plus A4 square to the power 1 by 2 into B1 square plus B2 square plus B3 square plus B4 square to the power 1 by 2 like this. Now the same thing, if you multiply, I'm just clearing this right now, and we want to find the answer to it. If we just do the multiplication here, that means if we say A1 into B1, this means 3 into 1. This is A1, for example, this, and this is 1, the number 1 here, the first feature, second feature, third feature, fourth feature like this. So 1 for the first feature, that would be A1. This person's feature, this means it's 3 into king's feature. For the king's here, the points for or value for king here, for example, it would be 1 plus, now see this 3 into 1 plus 5 into 4, 5 into 4 plus 4 into 4, 4 into 4 plus 1 into 2. Like this, you'll calculate. Again, when you see the division, in a similar way, that would be A1 square plus A2 square plus A3 square. So it will be 3 square plus 5 square plus 4 square plus 1 square to the power 1 by 2 multiplied by, again, 1 square plus 4 square plus 4 square plus 2 square to the power 1 by 2. And when we see the final answer, and when we calculate it completely, we get the answer as 0.94, as 0.94. This means this word man and this word king are very much similar. When we talk about the distance, distance equal to 1 minus 0.94, that would be 0.06. So it's very nearby, right? So when something is very nearby, this means it's very much similar. So this is how we calculate similarity. So this is what cosine similarity does, and this is how cosine similarity actually exists. Again, there's something called Euclidean distance. We already discussed about this. Just to calculate the distance, least is the distance, more similar is the word. Now, once you understood this, okay, this thing is very clear. What is similarity search? Again, there is something, there are other different things in similarity when it comes to similarity search. For example, here, now you see there are different method, hierarchical, navigable, smaller world, similarity search. The same thing in the similar way, there's another method called ANN, or approximate nearest neighbor. Please write it in your copy. Okay. There's something called ANN, approximate nearest neighbor. Again, it is talking about similarity. And we are not saying, again, you can use cosine similarity or you can use KNN2 here. KNN is nothing but K nearest neighbor. K nearest neighbor. So we notice one thing, we are not talking about the perfect answer. We are just talking about the nearest answer or the closest value or the most similar value. So now here, if we see approximate nearest neighbor, now there are different method of it. You can just Google this after the session. There's HNSW, IVF, IVF, SQ8, PQ, IMI, and NOI, and RNSG. Different methods are there, right? Now, randomized nearest neighbor graph, approximate nearest neighbor OEA, and inverted multi-index, product quantization, inverted file index, hierarchical navigable small world. Now, there are different things. In very simple terms, if you have to understand, we do similarity search. Okay, so what happens in similarity search? Now, till this part, is everything clear? We have corpus. Corpus will go and become token. Token will be embedded. After embedding, it will go to the vector database or the vector store like FAISS, Pinecone, Chroma, this VV8, Milvus, etc. Till this part, we are just doing this. Now, here the similarity search happens, right? Understand these things. In vector store, here the similarity search happen, and that's the reason we have it here. Okay. Is this very clear till this part? Is there any question, friends? Clear? Okay, Joseph, great. It's very clear. Let's move further. Okay. Now we'll see the complete process. Why actually similarity search matters. Okay. Now let me just go to YouTube first, and if we let me check if we have our friends have any question. YouTube. Again, you must be thinking, why am I going to YouTube like this rather than just continuously being here? See, again, that may be a problem. I may hear some sound if it automatically turns on. Okay. LN embedding is nothing but just converting those vectors into some numerical form. Okay, I don't see any name. Word embedding, again, premier top selection, basically Arun. We talked about the same. You can see the previous part and you will understand it. What is word embedding and all those things, how we do embedding, what is the intuition behind it, everything is given. I hope everything is clear. Okay, I don't see any question here. Okay, fine, not an issue. Friends, please be here till the end. At the end, we'll be seeing whoever is present, we'll be continuing with them. They'll be getting certificate. Okay. Now let's move further. Now in ChatGPT, what happens, friends? ChatGPT, you clearly know there is already this software, there's already a language model working. Fine. Now, when you are giving till this part, you understood that when we have data, tokens we make, then we do embedding, we store it in a vector database where similarity search happens. How the similarity search works? Now, consider you have trained the same on the similar way. Let me just go back directly. It will be clearer for you if you see it from here. Okay, now focus here. Vector store, there are two inputs. One is from the data that we gave, and one is another data here, another input here. Now, what is this input? Now, whenever you're asking question, whenever you're typing something, right, what happens? The same process continues. You are giving what? You are giving a sentence. If you are giving a sentence, the same thing will be converted into chunks. For example, you just do a basic Google search. What is generative AI? Fine. You did a basic Google search. What is not Google search? Sorry. In ChatGPT, you search what is generative AI. So what happened? Your question is broken into tokens, and your tokens are again converted into this embeddings, and your question embeddings are further sent to this vector store where it will clearly search. For example, you have the word generative AI. When you have given the word generative AI, it will search what is similar to this word generative AI, and whatever information you will have, depending on your input, it will be giving that further. See this. We have vector store here. Your question is going here. We have vector search. We have vector storage. Now the same thing. This is a vector store. What is happening here? Vector search is going on, and what we get? Top matching chunks. What are similar words, or what are the matching words in that database or in vector database, which are what are the words that in vector database which are similar to what you have asked, or which are similar to what question you have asked. Okay, the same thing goes here to get the top matching chunks, and here based on that the answer is prepared. How the prompt is prepared? Based on the matching chunks, whatever information, the matching information, and what is the question that you asked. Both the things are taken into consideration. Now the same thing is given to the large language model or small language model. Try to understand one thing, friends. When we talk about large language models, these are trained on data itself. This is the extra data that we are talking about, the PDF file, for example, that you attach. What happens there? When we talk about large language models, they may be open source. For example, using Hugging Face. Or they may be commercial, for example, using OpenAI. Or for example, DeepSeek. And then once you make the model, you will get the answer. Finally, this is the complete process that happens. And if you know this process, you will be in a really good position when it comes to interviews and all. Okay, you make the prompt, you have large language models, and you get the answer. Now, one process is very clear. Again, let me just revise this process. You have corpus, excuse me, to convert the same into tokens or chunks, you call it, that's fine. Embedding is done. Same embedding is stored in the vector database. Fine. Now, is the same thing is stored in vector database. You give your question, the question is embedded. Here, similarity search happens, right? And whatever is the matching chunks along with your question, whatever questions you ask, prompt is prepared, and after that, the same thing is given to the large language model. The information, the same matching chunks are given to the large language models, and large language model then prompt your answer. Okay. This is the basic part when you have large language models and you are giving extra file or extra information, and you will get the answer. Basically, you should remember that similarity search is very important, and whatever happened before that, you have seen. Okay. So this is a basic process that is followed even in RAG. When we talk about RAG application, this is a typical diagram of the RAG application itself. Now, RAG application is what? RAG is retrieval augmented generation. Let me just talk about it. RAG. RAG is nothing but retrieval augmented generation. Now, what happens in RAG? When we talked about the large language model, or whenever we talk about large language models are generally trained on massive data. But they may not have an answer specific to a particular requirement. For example, if I just ask about if I ask to large language model about the state Kerala, right? Now, if we ask about Kerala to large language model, just because it is trained on massive data, it may be able to give answer about Kerala. In fact, a lot of answer regarding Kerala. Again, God's own country and all those things. But if we talk about your respective college, it may not have all the information about your respective college and the process that is followed there. The large language model may not have that information. So what do we do now? What we do? We give this information as a corpus, as a supplementary to this, as a supplement to this large language model. Okay, as a help to the large language model. And this process of getting information from large language model as well as from your corpus is nothing but retrieval augmented generation. Understand one thing, since LLM is already trained on massive data, it will anyway generate the answer when you give something, when you ask something. But when we talk about specific application where you want to give PDF and you want answer from that specific PDF, you use the technique RAG, where it is retrieving or getting the answer from the PDF. And that is the reason we have the name retrieval, because we are retrieving from this source. Retrieval augmented generation. Anyway, generation is done by LLM, but that generation is helped by, or that generation is augmented by the retrieval that is done from the document that you gave, right? And that is the sole reason the name retrieval augmented generation. Now, when we talk about optimizing the large language models, right? Whenever we talk about optimizing the large language model, try to understand there's something called RAG already, right? Now, RAG, you give some prompt, you get the information, right? Okay, I have a question, I guess. Exactly, Kevin. And this is the reason when we talk about the model, it doesn't possess enough information. This is where RAG comes into picture. Or what do? There's another method called fine tuning. Okay. For example, this is the reason when I said we are giving extra information. If you are in any college and that information is clearly may not be available with the LLM. So what do? We get this information, the LLM gets this information from this, or the generation of the information is done is based on this external document. And just because this generation is augmented by or helped by this retrieval of information from here, that is the reason it's called retrieval augmented generation. Okay, Kevin, I hope it's clear. Okay. Now, in this thing, just focus. that when we are talking about large language model, if you want to optimize the content, what do we use? We use proper prompt and RAG. When we use RAG, here, the optimization of large language model is less. Fine-tuning, Atulya, I'll be talking about it, right? I'll be talking about fine-tuning too. Don't worry, we have a lot of portion left. Before this, I'll need to talk about the large language model itself, and then I'll talk about fine-tuning. Because when I talk about BERT and fine-tuning of the BERT model, that may not be clear for you. Okay, I'll be coming back to this. You have a large language model. How you are enriching the content using RAG. Okay, Atulya. Using RAG, you are optimizing the content. Now, this part is very clear, right? You have optimized the content, but at the very same time, if you want optimized large language model too, that will be having optimized content, then we'll be going for fine tuning. We'll be talking about fine tuning later. Don't worry, it's part of the today's syllabus itself. Okay. Okay. Now see this. How the model actually works. You have the model, foundation model, large language model. You use prompt engineering. You give prompts. You evaluate the same. Now, once you evaluate, you may need more information. If you need more information because it's not giving proper answer, so there is improvement loop. What do? You may use RAG, right? To evaluate RAG you use along with LLM and you evaluate the same. If more information is needed or better model is needed, you fine tune the model itself. And again, you evaluate. Once you get the proper answer, you deploy the model and go for monitoring and maintenance. Right. I'll be coming back to it. Don't worry. So we'll usually use RAG whenever we attach PDF. Exactly, Fareen. Whenever we attach external document, right? This is where we are saying it is retrieval augmented generation. Okay. Now, for example, just to bring more clarity to your concepts. Okay, Farid. For example, if I have to search what is RAG, I was supposed to cover RAG later, but fine. RAG, or retrieval augmented generation, is an AI framework that combines the strength of information retrieval and generative language model. It enhances the capability of large language models by allowing them to assess and incorporate external knowledge sources before generating responses. You understood one thing? External knowledge sources, maybe your PDF, by taking information from PDF, retrieving information from your PDF, it is generating something. So now it is retrieval augmented generation. Your generation is augmented by the information that you gave. It's just made better by the information that you gave. Okay? Okay, fine. So is this in clear, team? Now we'll go for the journey from transformers or from basic RNN to transformers. We'll talk about it completely. Before this, is the basic process clear? Now after this, we'll be talking about large language models and then we'll combine both together. And we'll talk about prompt engineering after that, so that you will have crystal clear conceptions. Okay, Farheen is clear. What about others, friends? Please comment in the chat box. Please be very active. Is it clear for you? Okay, for Alexander, it's clear. Rennie, it's clear. Joseph, it's clear. Okay. Joseph, it's clear. Sharon, it's clear. Okay. Akash is clear. Okay, great. Okay, friends, let's continue with the discussion. Srijit is clear. Joseph is. Yes, Joseph. RAG is generally one of the method that we use for taking external knowledge. Here, when we talk about large language models, right? RAG is the one which we go for. Okay. Okay. Okay, friends, and Sanmaya is clear, and we talk about Elna is also clear. Okay, friends, let's continue with the discussion. Just a minute. Okay, friends, this part is done. Now let's talk about the journey. Before this, okay, let's see if our friends on YouTube have some question. If they have any question, we'll be answering that, and we'll be moving then. No, please. Okay. Okay, clear, right? Okay, I can see a lot of clear. Data privacy in ChatGPT, Harsha, this is a big question actually. When we talk about data privacy, again, and that is the reason we generally we can't say that it is data will be secure and all. See, initially ChatGPT doesn't used to store your data, but now ChatGPT has the capability to store your data too. So data privacy is a big problem when we talk about large language models and all those things. Difference in ChatGPT and DeepSeek, Alan. When we talk about ChatGPT, it's again a large language model uses GPT there, and it's by OpenAI, one company. When we talk about DeepSeek, it's by another company that is based in China. It's similar to, for example, using Ghadi detergent powder and Surf Excel, for example, or using Ola or Uber, right? Both are doing the same thing, but it's just that owner of it are different. Okay. When require information beyond the data stored in vector cases, we need data to be retrieved from external sources, internet. How do they do? Again, Derkio, in that case, we can use APIs, so we can connect API. And nowadays, when we talk about agents, they are using API and get the information from that. Okay, you see. Okay, I don't see other questions here. Okay, friends. Let's continue with our discussion on journey from RNN to transformers. Okay, great. Let's go faster. I have to go here, right? See, Joseph, now both the things. When we talk about saving search history, it's really good, it's really convenient, but at the very same time, there is risk too. Data privacy, when we talk about this new world or new age, it's a big issue, right? There is no international body to guide for the same. It's all here and there, honestly speaking. But again, till the time you are not very considerate about data privacy, it will be fine. But at the very same time, data privacy is an issue. Okay. Second thing, when we talk about ChatGPT, for some time it will be easy for us to use. But at the very same time, in real world, for example, if you are working for a client, if you have the data, client data, don't give it to ChatGPT, right? That is clearly breach of data. Okay, that would be a problem, and that may be a problem in future if you do the same. Okay, so it's easy for us to understand all these things, but make sure that data privacy and ethics, for example, when we talk about ethical consideration, we'll be discussing about the same. Ethical consideration also is something that is a big problem when it comes to generative AI here or large language models. Okay. Okay, Joseph. Great. Now let's continue. Okay, this part is covered. Attention mechanism. Okay. Before attention mechanism, we have sequence to sequence model, auto encoders. Okay. Before this, let me talk about few more things. RNN. Understand, whenever we talk about neural networks right now, if we talk about neural networks, if you are from CS background, now this thing would be very much easier for you. When we talk about neural networks, we deal with what type of data? We deal with unstructured data. Again, we deal with structured and unstructured both, basically, structured and unstructured. There is ANN, artificial neural network, that generally deals with structured data, right? Then we have CNN, or convolutional neural network, that deals with image data, or for example, video data. And there is something called RNN, right? Now, RNN, recurrent neural network. This deals with text or audio data. Basically, dealing with the sequence data. Sequence data means what? For example, if I say I am a data scientist, doesn't matter how I say that, whether in text or in audio, always this will be followed by this will be followed by this will be followed by this, and this, right? Now, always I am a data scientist, there is always a sequence that we are following. This is something that we clearly understand when we talk about text or audio, and for that RNN is used, or recurrent neural network is used. Now, so when we are talking about data, that is text data, let's focus on text data first. Later, we'll talk about image data. Later, we'll talk about diffusion model, clip, and all those things. Now, first, if we talk about here, RNN. Now, RNN was a very famous architecture, right? And very famous. When we talk about neural network, it's a very famous algorithm, a very famous architecture it had. But RNN had a problem. Now, to understand RNN and what was the problem we need to go to deep learning part, and that will take approximately 2 to 3 days to cover, right? So I'm not going there. I'm just giving you some keywords. You can clearly search, and just whatever gap you have, you can plug that gap, right? I'm just making sure that I explain each and everything that is there, but I'll be giving you some words, and please go back and search for it, right? So that whatever gap you'll have after this session, that will be plugged. Because again, as we discussed, paucity of time, we can't cover each and every portion. So RNN is recurrent neural network, takes sequence data. In RNN, the only problem was RNN can easily store memory, and it was really good architecture, but the problem was vanishing and exploding gradient. Exploding gradient. Please feel free to search for what is vanishing and exploding gradient. Okay? RNN used sequence data. Okay? Now, since RNN had this problem of vanishing and exploding gradient, sometimes weight updation wasn't possible. Whenever we are talking about this, along with vanishing and exploding gradient, this is work for you. Since we are not dealing with RNN here in this session, please search for weight updation, how weight is updated basically in neural network, right? All those things. Once that is clear, it will be vanishing and exploding gradient will be clearer for you. Okay? What is error surface? Right? What is loss? Loss function? What is cost function? Just search for all these keywords. Okay? So it will be easier for you to understand. What is backpropagation? Propagation. All these things. Please search on all these things. Weight updation in neural network, huh? Well, weight updation in neural network. Error surface, loss function, cost function, backpropagation. So this vanishing and exploding gradient will be very clear for you. Now, RNN had this problem. This problem was solved by a new architecture called LSTM. LSTM is nothing but long short-term memory. solved by LSTM, long short term memory. LSTM uses gates. RNN used to used to keep everything in memory, and LSTM uses gates. For example, there is forget gate, there is input gate, and there is output gate. Okay. Now, using these gates, it minimized or solved the problem of vanishing and exploding gradient. Okay. Now, LSTM is nothing but an improvement over RNN, LSTM, RNN, and then there is one improvement done. Improvement is LSTM. Now, similar way, above LSTM, there is one more improvement called GRU. GRU. It's not Mr. GRU from Despicable Me. Okay, it's GRU, Gated Recurrent Unit. Gated Recurrent Unit. GRU. Now, in GRU, it had, since here it had 3 gates, GRU had advantage of having only 2 gates. It was faster than LSTM. There were 2 gates. There was update gate, and there was reset gate. Update gate and reset gate. Great. Now, once it's done, now what are the things you need to search for? I'll just explain these two so that it will be easier for you. I'm just clearing this. Once this is done, search for RAG, search for RNN, LSTM, and GRU. See this, RNN, LSTM, and GRU. Okay, these are types of RNN itself. When we talk about LSTM and GRU, these are just a basic improvement over LSTM and GRU. And when we talked about different gates, right? Here, these are RNN, LSTM, and GRU. How the architecture looks like, and all those things, you can just do basic Google research, and you will get the information. Right. Now, limitation. Now see, they struggle with long-term dependency because gradients vanish or explode during backpropagation. So the same thing I asked you to research. Backpropagation, vanishing and exploding gradient was a problem, right? So this was a limitation that we talked about, making it difficult to learn relationship between distant elements in sequence. Fine. Once this is done, please research about LSTM, long short-term memory. Long short-term memory had gates, right? What gates we talked about? Input, forget, and output gates, right? What it did, it regulated the flow of information. So what you need to remember, what you need to forget, all those things can be easily understood. And what it did, it effectively addressed the vanishing gradient problem and enabled to capture the long-term dependencies, right? LSTM are commonly used in NLP, so LSTM is very important. Similarly, a simplified architecture over LSTM. LSTM had 3 gates. GRU simplified the same thing, simplified the LSTM architecture by combining the input and forget gates. The input gate and forget gate were combined together to form the update gate. So there were 2 gates we talked about in GRU, update gate and reset gate. So because of which information flow was proper. Now, GRUs are often preferred when computational resources are limited. Why? Because LSTM is more complex than GRU. GRU is less complex than LSTM, right? So this is very, very clear. Then simplification makes GRU computationally more efficient and faster to train than LSTM while still being able to capture the long-term dependencies. Now, I hope this is making sense to you. Now, when we come back and we see what we have written, it will be easier for you to understand. So we had RNN. RNN used to process the sequence data. Again, let's not forget LSTM and GRU also are type of RNN itself. This also use the sequence data. Sequence data uses the sequence data itself. Now, RNN had problem of vanishing and exploding gradient. This was solved by using LSTM. LSTM had 3 gates: forget, input, and output gate. Forget gate and input gate combined together to form the update gate in GRU, gated recurrent unit. Right. Now, once this part was done, over GRU, next part came, that is, let me go back to slides. After GRU, this part came. Autoencoders, sequence to sequence. Now see this. From here, we are moving towards this. Yes, there's some question. Yes, Joseph. LSTM and GRU are improved version to treat the problems of RNN. RNN had the problem that it can't remember the long-term dependencies because of the problem of vanishing and exploding gradient. Okay. Now, let's move further after this. Okay, Joseph. Now, here, let's talk about, now you know there is something called LSTM. And what LSTM does, it's used for sequence data. Sequence data, that is text or audio data. Now, we'll see. There was something called sequence to sequence mechanism, right? Or sequence to sequence algorithm we talk about. Once you understand what is LSTM, there was something called sequence to sequence to sequence algorithm, or sequence to sequence mechanism, you can say. That will be fine. Sequence to sequence mechanism. Now this, when you are seeing this sequence to sequence, understand it is just an improvement over RNN. Now, again, that was RNN and GRU, all those things. Now we use multiple LSTM or multiple GRUs or multiple RNN, depending on our requirement to make encoders and decoders. Now, this is very much important to understand what are encoders and decoders. Now, why is this important? If you understand encoders and decoders, you will understand which type of model you use when you are making generative AI models. Okay, let's go further, friends. We have very less time. Let's move further. Now, see this. When we talk about this, see here, always there is initial hidden state and everything in LSTM, in RNN, for example. Now, consider these are some tokens. These tokens, on this token, embedding is done. Now you clearly know what is embedding. We have seen embedding is done, and each and every word is given to each instance of LSTM. Now see this. LSTM, 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 LSTM. Now there are, depending on number of words, we are using LSTM, right? Now see this. RNN, LSTM, GRU, depending on number of words. How many number of words we have? Depending on that, we are using LSTM. So number of words will be equal to LSTM. But before that, yes, first understand this architecture. When we talk about sequence to sequence model, there are two things. One is encoder architecture, one is encoder, and one is decoder. In sequence to sequence, you give input to the encoder. The input is converted to context vector or thought vector. Context vector or thought vector. Now, see, why the context vector? Basically, you need to remember the word context vector itself. The context vector is also called thought vector because now when the paper, in the original paper of the sequence to sequence mechanism, they have written the line encoding as a thought. And that's the reason when we do encoding, the context vector that we get is also called thought vector. Because this is what they had mentioned in the original paper itself. Fine. Input, encoder you make, you get context vector, and the context vector is sent to the decoder itself. The context vector is sent to the decoder, and from the decoder, we are getting the output. Right, from the decoder, we are getting the output. So, now see, what happens inside the encoder actually. This is the encoder architecture. In encoder, there are a lot of LSTM, and we can use RNN, LSTM, GRU based on our requirement. Most of the time, we are using LSTM and GRUs. Okay. So if computational power requirement is less, then we go for, or less computational power we have, then we'll go for GRU. In general, we go for LSTM. Most of the time, people still prefer LSTM. Now, okay. So LSTM, what is happening? Learning natural language processing. Now, all these are converted into a vector and they are stored in this context vector. From here, if you see, the same thing information is going here and it is stored in the context vector. Now, decoder, what decoder does? It takes information from the context vector, that is, it takes information from the context vector and it has two tokens extra, start and end. It will start, it will take information or context for this particular encoder. From context vector, it will get some information and it will give the first word. Translation we are doing, okay? Translation if we are doing, for example, natural language processing, apparently, again, whatever is written here, I shouldn't pronounce it. I'm not that good at it. So see here, it will start encoding, decoding will start here. It will take information from context vector. It will give the first word. Fine. Now, since the first word is already there, it will go to another LSTM. It will take information from the context vector again. Basically, previous LSTM had the information of context vector, and you will come up with the next word. Again, you will come up, we'll go further. We are giving the information that this word you're giving here. Since this word already has the information of this word, it is going further, and the same thing goes further here in the next LSTM block. Let's not forget the context vector is already coming from here. We are getting the context information from context vector. The same thing goes further. It will again go to the next LSTM, still have the context vector. Still we are going for, it will give the next word. The same thing will go further. Context vector, next word, go further, context vector is coming already. And we got the end. So what are we getting? We are getting the complete translation of this particular sentence. The same sentence is translated here in this way using sequence to sequence mechanism. Okay. So again, to repeat that, we have this sentence. The same thing, each and every word goes to LSTM. In general, we say this is time t, this is time t minus 1. At the first instance, this is time t t plus 1, t plus 2, t plus 3. Again, it goes to a bit technical. It will be a bit lengthier. Let it be. Okay. Now, context vector in the second input every time, which is yes, Fareen. See, when we talk about this, right, context vector, yeah. See, when we are taking context vector, this just means this hidden state that we are talking about, right? This is just a memory. This means when we are talking about this memory, context vector, when you are giving this to LSTM, this LSTM is already having this memory. Okay, this context vector. And that's the reason when we are going further with this, I said the context vector is also coming because it is already inside this LSTM. Again, next LSTM will already have the context vector from the previous LSTM, like this. Okay, is it clear, Fareen? So yes, it is taking the context vector completely. Yes, Fareen. Okay. Now, okay, this is sequence to sequence mechanism. Now, what was the issue? Now, what was the problem here? The problem here was that the context vector was of fixed size. This was a big problem. The context vector was of fixed size. Now think of it. If you have shorter sentence, that is fine. But if you have a longer sentence, a very long sentence, and you'll have a lot of embeddings, and the context vector is of the same size, so what will happen? It will lose the context, right? It won't be able to capture the complete meaning of a sentence because of this limitation. Now, this is a big problem when it comes to context vector, right? Now, that is the reason we needed an improvement over the sequence to sequence mechanism. Now see this, read this. Fixed length context vectors struggle for with long sentences, often failing to capture the full meaning when sentence length exceeds training example. Limited capacity leads to information loss. That's a problem, as longer inputs dilute attention per word, reducing output quality in the long sentences or long sequences. This was the problem in sequence to sequence. So remember, whenever you have to remember sequence to sequence, as a gist, sequence to sequence has encoder and decoder. From encoder, it goes to context vector, and then it decodes using the context vector itself. But the context vector, the problem here is context vector is of fixed size. I'll just clear this. Context vector or thought vector is of fixed size. That is the problem. And that's the reason we have to go for the next concept, that is attention mechanism. Now, attention mechanism is an improvement over sequence to sequence mechanism. Now, understand one thing, when we said sequence to sequence, it is still using sequence data. Attention mechanism still uses sequence data. Okay, this is very important to understand. Still, we don't have this quality. We don't have that property to take the sequence data or use any other data itself. We are still using sequence data. Okay, this will take time to explain. Now, okay, till this part, is everything clear, team? It's already 1. Okay, so tell me, till what time will we having break now? So till what time we should take break? Okay, Joseph, great. What about others, team? Is it clear? Do you have any question for this particular till this time? I hope everything is clear. We are going extremely clear, right? Focusing on each and everything properly. Okay. Okay, Farin, it's clear, right? Okay. So we'll do one thing. Now, tell me, how long should we have this break? 30 minutes or 45 minutes? Considering we are considering the topic itself or the content itself, What do you think? What would be the good time? Because we are having this session till 4:30 or 4:45 only. So we'll have to cover a lot of things. Tell me one thing. For 30 minutes or 45 minutes? 45 minutes. 30 minutes. Joseph is saying 30 minutes. Farin is saying 30 minutes, but I'm getting a lot of 45 minutes too. A role of LSTM and Alexander, the role of LSTM is very simple. It's just there to take that input from the data and store the data, nothing else. To take the previous input and store the data and give the out. Go further. Give the memory to the next one. Okay, Sajan is saying 40 minutes. Okay, let's go to the sweet spot itself. We'll take 40 minutes or so. Okay, guys, see 45 minutes may be a bit longer because I can see a lot of people are saying 30, a lot of people are saying 45. So, okay, let's take a 40 minutes break. That will be the middle ground, right? Okay, before we go further, before we go for a break, let me check here on YouTube if our friends have any question. "45 minutes, friends, that would be too long. There are many people who are just asking for 30 minutes. So, okay, let's just go for 40 minutes. That will be fine. Right. So, because we have to cover a lot of things. See, there are a lot of interesting things coming up. Okay. And Shambil, okay, we'll do one thing. Once I come back, right? Once we come back from the break, till 1:40 we'll have break. I'll come back. I'll just again explain the same thing, sequence to sequence. Anyway, I'll have to explain, and then we'll continue. Use cases of generative AI, Ellen, we already talked about when we were discussing the initial part itself, right? We were talking about generation of a new content using maybe video, maybe audio in that way. Okay. Okay. Now let's take break. Let's come back by 1:40 and then we'll continue. Okay. So 1:40 p.m. it is, friends. I'm not closing this session. I'll just stop sharing the screen. But yes, right now we are continuing still. Okay. So 1:40 it is. 1:40 will start again. Okay, Joseph. Okay, team. Yes, I have one more. Sabrina. Okay, Sabrina. Okay, guys. Take care, team. Please have your lunch. Come back stronger. Come back fresh. There's a lot of things in the kitty. Please come back and yes, we'll discuss it again. Okay. Take care, team.
Palestinian legal permanent resident of this country, his wife is 8 months pregnant, out of his Columbia University apartment. As of this morning, he's in ICE custody in Indiana. Secretary of State Marco Rubio posted that they're revoking Mahmoud's green card. Let's be clear, Mahmoud hasn't been charged with any crime. He was kidnapped by the Trump administration because he participated in campus protests in Colombia against the genocide in Gaza. Palestinian students in Colombia are now reported to be terrified of coming to class and are locking themselves up in their dorms. This is a blatant assault on the First Amendment, a sign of advancing authoritarian
Hey friends, hi. I hope you guys are back. We'll wait for 2 more minutes for our other friends to join and then we'll continue. Hey guys, hi. I hope you people are back. Let's continue with our discussion. I hope you guys had lunch properly. Okay, now, okay, Joseph, great. Okay, team, let's continue. And yes, by the end of the session, I'll be posting a Google form, right? Not just here, even in YouTube, right? Please fill the form and we'll make sure that you will get the uh, certificate too. Okay, I'll be posting the Google form here as well as on YouTube for our friends who are watching this on YouTube. Okay, so let's just revise it first. First of all, we talked about generative AI. What is generative AI? We talked about the different applications, and again, all those overview we saw. After that, we went for the complete process that we follow during RAG. What are the basics? We talked about the multiple document combined together to form a corpus. Corpus is the basic data we're talking about. Fine. From corpus, what we do tokenization. Again, not just tokenization. When we do tokenization, there is stemming and all those things, but that's not the matter right now. Tokenization. After tokenization, we go for embedding. So corpus. I'm just scribbling now since we already have seen it many times. Corpus. We talk about tokenization. From tokenization, we went to embedding. In embedding, where do we store these embeddings? We store it in vector store on vector databases. In vector databases, what do we do? What are the different vector databases we saw? There is, for example, FAISS, Facebook AS similarity search. There's Milvus. There is Chroma, etc. Now, in vector database, what happens? Similarity search happens. How does similarity search works? You give some input, you get again, you make tokens of it. We do embedding of the same. Once embedding is done, you go to the vector. Again, the same thing goes to vector database. Here similarity search happens, and then what do we get? We get the prompt ready. The same thing will come here, and two inputs. It will understand what are you giving as an input. The same thing will go to the large language model, and large language model will just generate your answer. Now, till this part we have seen. After this, in similarity search, of course, when we talk about embedding before this, we talked about word to vec, we talk about CBOW or continuous bag of words. We talked about skipgram, this fast text, all those things. Also, when we talk about tokenization, there is tetra tokenization, sentence tokenization, there is unigram, bigram, trigram, all those things. Once this part was done, we discussed what is RAG. And now we want to go for a large language model. How the large language models came into existence. Here, we talked about RNN. What was the problem RNN was facing? RNN was facing problem of vanishing and exploding gradient, due to which it was not able to remember the long-term dependencies that we have in data. Now, because of this, the improvement that was needed was provided by LSTM. It had 3 gates. Input gate, it used the gate basically to forget some information that are not required and remember information that are required. So LSTM, long short-term memory, used 3 gates. It used forget gate, input gate, and output gate. When we talk about GRU, gated recurrent unit, it was upgradation over LSTM to make it more simplistic using two gates, that is update gate and reset gate. Now, RNN, LSTM, GRU, everything, all these 3 were following the sequence data or using the sequence data itself. Sequence data, text, and we talk about audio, all those things. Now, after that, we talked about sequence to sequence model. Sequence to sequence model uses those LSTMs, right? You get the input, and what it does, it just converts all the information, all the embeddings you have into context vector. Once you convert that into context vector is also called thought vector. Now there is decoder, and that has a lot of LSTMs. You give context vector, it will be start token, it will give the output, and the same thing continues further here. You give the first word, based on the previous word itself, it will give the output. Context vector will still continue like this, right? Again, there will be next word here, we give output, here there's input, like this. We have encoder and decoder. Now, when we're talking about encoder and decoder, let me just go back to this part. For now, we need to understand that there's attention mechanism after this. This encoder, it has LSTM and all those things. We give it to context vector. Context vector has lost, again, there's decoder that has lost a lot of LSTM depending on number of words. And again, it will take information from context vector and give the output. Fine. After this, what we need to focus on is guys, yeah. Please be on mute. Okay. what we need to focus on is attention mechanism. The only problem was the context vector that we talk about was of fixed width. Okay. Now, attention mechanism was made to get over the problem of fixed width. Fixed width in the context vector. Now, once this part was done, part will be done. Just make sure that you search for attention mechanism paper. Okay, original paper. See, make sure that you are going for all these papers, not just here and there. Okay, every information is fine, but the original paper always holds much more value. Now, okay, attention is all you need is something that we'll see later, that will come. Okay, question answering multi-generative model. Attention is all you need is basically, that is a paper that came in 2017. I'll be talking about this. We'll be talking about sequence to sequence model we talked about, right? For machine translation. Yes. Sorry, attention and solution to working problems. Exactly, Joseph. Exactly. Attention mechanism came into existence, and attention mechanism solved the problem of fixed width or fixed length of the context vector. Now there are different concepts. For example, hidden state. Hidden state that we talk about is nothing but memory. So what it did, for example, there's one LSTM. In previously, what happened in context vector, in sequence to sequence, one LSTM followed by another LSTM followed by another LSTM. Here, what do we have? Here we have LSTM, we have hidden state, LSTM, and we have hidden state. Hidden state is nothing but the memory. And then we have LSTM and then hidden state. We take these hidden states into consideration, and hidden state will have all the important information from that LSTM. So now each and everything is in memory. Now decoder also has some hidden state. It's not given here, but now we are focusing only on hidden state itself, not on anything else. We are focusing only on hidden state. Hidden state, whenever you hear the word hidden state, understand we are talking about internal memory. Okay, remember this, we are talking about internal memory. This means this hidden state had the information of this word. This hidden state has the information of whatever was here, basically this, and whatever information it got from this hidden state, that is this information. So this hidden state will have information all these based on all these things here. Okay, now you have this hidden state. What do you do? For each decoder, there is a hidden state. Okay, so what will you do? You will take each hidden state, decoder hidden state and encoder hidden state. Now focus on this theme. Now this is not very important for generative AI, but it's important for you to understand how to overcome the problem of context vector. Right, now we have limited time. I'll need to go a bit faster. Now understand hidden state of LSTM, the encoder, and hidden state of each and every LSTM from decoder will multiply to give the scoring function. Now scoring function will do what? It will just tell, okay, this much for this particular hidden state on this position, this much is the value. On this particular hidden state, on this position, this much is the value. It will come up with some score. Okay. Now, weight of input token for predicting the output token. Basically, based on this hidden state, when it multiplied with this hidden state here, it understood that how important this word is for this particular location. Second one, when it multiplied, how important this word is for this particular location. How important this word is for this particular location. Similarly for this, this and this. Similarly for this, this and this. So what did we get? We get the weight of input token for predicting output token. How important this input token is to predict output token at this location, and this location. How did we get the importance of this? Based on this hidden state and multiplication of this hidden state with each hidden state. Now, after this, The encoder decoder LSTM unit outputs a hidden state D. See what I said? For each decoder LSTM, there will be an hidden state 2, right? Now, that D is used to compare with each of the encoder hidden state. For example, there will be one encoder, it will just multiply with each and every encoder hidden state. Now this, we'll get what? We'll get some score, attention score. What it gives, it just tells you how important each and every word is. Okay, now we got the importance. Next we go for is out of this now, here we'll have is decoder, and now after this there will be a softmax function. Softmax is an activation function. What is activation function? Please search for it. Softmax is an activation function, and what it does, it converts the scores or attention scores to probability. Converts attention scores to probability. Right? You get this, and you multiply attention score. You take the softmax function, you multiply it with each and every hidden state. So what will you do? You will get the probability. And this, for example, how much is the probability of first value, second value, third value? Based on that, you'll get weighted hidden state. How much is the probability of first value? How much is the probability of first, second value? How much is the probability of third value? In this way, you will get the context vector. The weighted input hidden state vectors are summed up, and this summed up vector represents the context vector. Now here also we are making context vector, but it's just that the context vector is not of fixed size. It will be depending on the number of words we have, because for each word there will be hidden state. Okay, just an overview of this is enough. Again, you won't be working with this when it comes to generative AI, but just need to understand that attention mechanism is solving the problem of context vector by giving flexible context vector. Okay, flexible context vector. This context vector is flexible because of the hidden states we have. Okay, so what you need to remember, you have sequence to sequence. In that you have encoder decoder model, encoder and decoder model. The problem was fixed length of context vector, The same problem, again, to solve this problem, solution was attention mechanism. Attention mechanism was the solution for this. What it does, gives flexible context vector. Okay, gives flexible context vector. Because of this, the problem is solved. Now, two things you need to remember, encoder and decoder. Now, when people were using attention mechanism in 2017, now this is very recent, 2017. In 2017, there was a breakthrough, a paper, attention is all we need. That was by Google. Attention is evolved by Google. Mr. Vaswani, Mr. Ashish Vaswani is credited for that. Okay, now let me just Google this for you. This Attention mechanism paper, or I'll just say attention is all you need. Okay. Now you can come here and see what, just go and download the paper. I talked about Mr. Ashish Vaswani. He was the first author of this paper, right? And attention is all you need. Please go and download this paper and read this paper. Okay. Again, this is the original paper of itself. He is in Google. Everyone, in fact, was from Google in here. Just basic Wikipedia now will actually help you to understand. Attention is all you need is a landmark research paper in machine learning authored by 8 scientists working at Google. This paper introduced a new deep learning architecture known as Transformer. 2017, Transformer came into existence, and this became the base for generative models, large language models we talk about, right? Now, based on the attention mechanism proposed in 2014 by Vardeneu. Okay, now this is attention mechanism. When you see, you go back. Attention is a method that determines importance of each component in sequence relative to the other components in that sequence. Which word is more important right now for the output? This is what we have seen. It gives some weight to some each and every word, and because of that, we understand which word will go here, which word will go next. This is what is done in attention mechanism. It's very famous. It is considered a foundational paper in the modern artificial intelligence and a main contributor to the AI boom, the transformer approach that has been architecture of wide variety such as large language models. Now understand one thing, this is what is the base for the generative AI models or the large language models we talk about. Okay, now see this. At the time, the focus of research was on improving sequence-to-sequence technique for machine translation, but authors went further, forcing the technique's potential to other tasks like question and answering. This is for multimodal generative AI. Generative AI, you understand. What is multimodal generative AI? When we talk about multimodal generative AI, basically it is using more than one data type. For example, not just text, images, text, audio, and all those things, right? Now, when you talk about multimodal generative AI, or I should say here, not this. Not this, not this. Multimodal. This means having more than one modality, right? Modality is a classification of single independent channel of input-output. For example, when we say single unimodal, that means either you are going for text or image like this. When we talk about multimodal, you will have text as well as images as well as again audio. All those things can be combined together. ChatGPT for right now is multimodal model. Okay, multimodal generative AI model. Okay, fine. What we need to focus on, we'll focus on that. Okay. Now, I won't go on, I will give you an overview of this. But if I go on each and everything, that will be taking a lot of time. Transformers. Now, transformers came into existence. What do transformers have? Transformers will have a lot of such encoders. We know how encoders looks like. We know how decoders look like, right? We know what is context vector. We know what is context vector. We know what is encoder. We know what is decoder. Okay, fine. Now, this is a basic model. This is the encoder input. This is considered one encoder. This is this encoder complete. This is the encoder again, same encoder. This is the same encoder. What encoder has? Encoder has encoder input, right? Encoder input, you get the input sequence. Now there comes a word self-attention. Now what is the advantage of self-attention here? Understand one thing, that till now we were dealing with what type of data? Sequence data. But now sequence data is not required. Even if the data is not in sequence, it will work. When we talk about context, till now the focus was on sequence data. Now we are not focusing on sequence data itself. Okay, so doesn't matter now. So one of our friends had asked question, what if it's not in sequence? What if the grammar is not proper? That's fine, because now we have transformer. Transformer doesn't require that grammar and sequence and all those things. It just needs some words. Now, for example, whenever we give input, there is something called self-attention. Now, what is self-attention? Self-attention, there's another word, multi-head attention, you'll see. Till now, when we were saying sequence, for example, if I say Virat Kohli is an excellent batter, a batsman, fine. But here we are focusing on sequence, one after another. And we are not talking about the relation, or we are not talking about how each and every word is related. See, we are giving this, but we are not saying if there is any relation between excellent and Virat and Kohli and batter. We are not talking about that, right? But in transformer, well, self-attention came into existence. We are talking about the same. It will take one word, and self-attention, what it does, it checks how important or how related one word is with another word. For example, how related Virat is with Kohli, Virat with is and, forget about is and here, Virat Kohli, excellent, batter, Kohli, again is and also you can add, that's fine. I guess I have a question, Fareen. Fareen, see, and when we talk about n-gram, see, we are talking about relation only here, right? When we are taking one token, for example, Virat, there's no relation then other than that. We say Virat Kohli. The relation is there itself only. What about after that? There was no relation after that. That was basically when we talk about unigram and all, those things are useful when it comes to text mining. But when we talk about self-attention, we just predict how important one word is with respect to another word. In bigram, unigram, trigram, we are not doing that. We are just seeing how they are together. We are just focusing on how important one word is with another word. This is how ChatGPT does, right? It just understands what you're talking about, even if your grammar is not perfect. This is what ChatGPT will do. Exactly. Now, this is what happens when it comes to transformer, self-attention, how important one word is with another word. Understand this. Self-attention. A mechanism within neural network, particularly transformers, that allows the model to weigh the importance of different parts of an input sentence when processing it. Basically, talking about which word is related to which word, or which word is more important for which word, so that it can tell you about the next word that can be there. Okay. Self-attention is a type of attention mechanism used in machine learning models. This mechanism is used to weigh the importance of tokens or word in an input with respect to another word. Or here, self-attention is a technique used in NLP that helps model to understand relationship between words or entities in a sentence. Right? How important the word Virat is with respect to Kohli, like this. Okay. Now come back. Now, see, encoder, what happens? You are giving input, there's self-attention. Now, some self-attention, the input will go to self-attention. It will give the probability of each and every word. Okay, it will go to the next layer. The same input that you gave will also come here, right? Will also come here for residual addition and layer normalization. This means what? It might happen that here only you are able to understand the relation. But what if there is something missed? Right? Why to take that risk? So it goes here to the input goes here, and there we are doing layer normalization. Layer normalization and residual addition. If there is something missing, residual addition is what? If there is something missing here from the actual input, you will take it from this input here itself. Right. Now, and layer normalization, just normalizing the layer so that if there is anything that is very extreme, any word that is very extreme or any probability that is very extreme, that will be normalized. Again, the same thing, residual addition and layer normalization step. See, understand this. You have y, you have x. X is what? This. So you get z. Z equal to x plus y. Basically, it's taking both the values from here and here. And then it continues further. Feed forward network. Feed forward network, again, very much useful to get the output here. Okay. Now the same thing goes here. And if there is anything that is missed, again, there is residual layer and normalization layer and encoder output. Fine. Now we get output from encoder. Always remember, whenever we talk about output from encoder, the output from encoder are nothing but representations. Remember this. Representations. These are nothing but output from encoders. Okay. Now see this thing. This is encoder. The same thing will go further. See, this is considered, this is this block, only this block. The same thing will go further. Okay. The same thing, if representation from here will go to the next encoder. Representation from here will go to the next encoder. Go to the next encoder. Go to the next encoder. And from here comes the output. From here will come the output, and it will go here like this. Okay. Now see this. In decoder, what is happening? And again, it will come here, go the output here, like this. Fine. In decoder, what is happening? In decoder, you have self-attention mechanism. Fine. At the very same time, you have encoder-decoder attention. This encoder-decoder attention is very important. Why? This encoder-decoder attention, when we talk about encoder-decoder attention, understand it is processing the encoder output. That is the representation that we talk about from here. Right? From here, encoder output will go and it will go here. Now, this encoder-decoder attention acts as a bridge between encoder and decoder. It acts as a bridge in between encoder and decoder. Okay, fine. Now, the same thing goes further. Again, there's residual addition and layer normalization in case something is missed. There's feed forward network. Again, there's residual information and there is decoder output. Okay. There is shifted input sequence. Shifted input sequence means what? Shifted input sequence means the input is actually shifted towards the right side. For example, here the target sequence that we're talking about, or the target sequence that we need here is the cat sat. Okay, the target sequence we need, the answer that we need here is the cat sat. Okay, now what it does, when it goes to the decoder, it won't give the value sat. It will just give the start token and it will give the value the cat, because already it should have some information from the encoder, right? So what will it do? This decoder, based on the encoder output, will predict the next word, that is sat. It will predict. Fine. It will go to the next word again. Next decoder. What decoder will do again? It will predict again the next word. It will predict again the next word. It will predict again the next word. These things happen so fast, and this is how you're getting output from ChatGPT. Tuck, 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 tuck. You get the output from ChatGPT, right? Why? Because the same thing, the same process. You give the mask attention, you give the mask process, mask this layer, and you go further, right? Now, this method of shifting input sequence, this is also called, here we talk about mask attention. Mask attention means what? The complete input is not given. Only the two words are given, one word is left to predict. Because if we don't do that, it will definitely be able to understand what is the input. It will be anyway giving the output, then what is the use of decoder? Mask attention, what it does, it masks the next value. We go for mask attention. Mask attention. Mask the next word. Simple. Here, consider predicting the token sat on the sequence. You give the target sequence, the cat sat. Decoder input you're giving start, the, and cat. Mask attention. It's just saying at the position 0, we have start token. Position 1, the. Position 2, cat. Okay, fine. If you are not doing this, decoder input will include the ground truth sat and causing the model to cheat, because the model already knows what is the next word. Why will it predict? Or even if it predicts, we clearly know the model is cheating, right? So this is what we do here. Now, next thing we focus on is self-attention working. Again, I should put this to you, but fine. Okay, no worries. Fine. Let's just talk about it. What's the time now? 2:48, right? 2:14, right? Fine. Now, how attention mechanism works? Now, this is a bit more in detail. There will be tokens. There will be query tokens. Now, for now, just understand that we have self-attention, and what it does, it focuses on each and every value. Now, this slide is just to explain you. When we are talking about self-attention mechanism, every word is broken down into 3 vectors. Every token, sorry. Every token or every word is broken down into 3 vectors: query, key, and value. Remember this. Query, key, and value. QKV. Query, key, and value. This 3 things determine how much important one word will be with respect to another word. Okay. Even in your interviews, if someone asks how self-attention works, you should remember there will be token. Each token will be divided into 3 parts: query, key, and value. Now, let's say you're talking about the sentence, natural language processing. Now, how important the word natural is with respect to the word language and with respect to the word processing. Or if you are taking the word language, how important the word natural is with respect to processing. Sorry, how important the word natural is with respect to language, and how important the word processing is with respect to language. Now, just a minute, team. Okay. Consider the word natural and language. What are you doing here? You multiply two things, Q and K. Q and K, remember this. Focus on this, take a screenshot, that will be fine, because this is something that you need to understand. If you're not able to understand right now, please take your time and go through it again. It is easy, I'll explain. Consider two words, natural and language. We want to see how important word natural is with respect to language. Okay, so it will be broken down into three things: query vector, key vector, and value vector. Language is the second token. This is the first token. So query vector, key vector, and value vector. Now, if you want to understand how important the word natural is with respect to language, what will we do? We'll take, first of all, we are focusing on the token language. We are focusing on the word token language, and we want to understand how important the word natural is for this particular token. Now, what will we do? We'll take Q2. Understand the multiplication is also always Q into K. So what will we do? We'll take Q2. This means Q query vector. And from here, we'll take K1. That is key vector of this particular word, because we want to see the importance of this word. We'll multiply this two. And just to want to see, if you want to see the importance of the word language with itself, we'll take the multiplication of Q2 and K2 like this. If you do Q2 into K1, Q2 into K1, you'll get some value, some score. Similarly, Q2 into K2, how important this word is with respect to itself, with this word with respect to itself for language. We'll take 160. Fine. Now, what we'll do? Q2 into K1, Q2 into K2, 128 and 160 we get. Fine. This clearly means when you are talking about language with itself, you are having more weight. Language with another word, you are having less weight. This anything, I mean, this is very basic, right? A word will be more important for itself rather than any other word, right? Now, you compute the score. Now, what happens? Previously in attention mechanism, you might have seen, whenever you compute the score, you pass it through softmax function, softmax activation function to get the probability. Fine. In that case, but here when we're talking about predicting the probability, the answer would be very huge, because you see the magnitude of these things, this score is very high. So the product will be very high, and that will be skewing the softmax function. Answer won't be proper, or it will be very high. So what do? We just divide it by dimension of this key vector. It will divide it by the dimension of the key vector. Now it may be 64, it can be 128, it can be 256, depending on the data itself. So we divide it by under root of dimension of k. And that's the reason we get the value S1 and S2. S1 and S2. And what do? Once we got the score S1 and S2, score is passed to softmax function. Will be passed to softmax function, and we will see this softmax, we are getting the score, how important the score is. For example, 16 and 20. So this value and this value. So we'll say the word language will pay 2% attention to the word natural and 98% attention to itself. Right. What we are focusing on? We are focusing on how self-attention mechanism work. Self-attention mechanism, focusing on this word, how important this word is, how important the other word is, like this. So this word, for this word, it is focusing on this word for 2% only. Okay. Now weighted sum, if you want to see how important each and everything, we are just doing a weighted sum here, nothing else. We are saying this is important, for this is this much important, this is that much important, that's it. Nothing much. Now, this vector now encodes language with context from the sentence, considering how relevant each token is to another token. Right? For language, how each and every token is important. This is what happens in self-attention self-attention, yes, self-attention mechanism. Now, understand one thing, encoder and decoder. Whenever we talk about transformer, there are two things, encoder and decoder. Transformers may be decoder only model 2. Transformers may be encoder only model 2. Transformers may be encoder and decoder model 2. Okay. Now, attention is all you need is a paper name. Now, encoder, what it does, it understands the input. Decoder generates the output. Focus on this word. Decoder generates the output. Now, tell me the answer. If I say Chat GPT, what Chat GPT is doing? It is generating the output. So what do you think? Chat GPT is what type of model? Is it an encoder model? Is it an encoder decoder model? Or is it a decoder only model? Or GPT when we're talking about? Now see this. Okay. Transformers when we are saying, no, Shivani, when we talk about GPT, right? I understand that there must be some confusion. Encoder, decoder, because we are not seeing decoder only. GPT and DeepSeek and all those things are decoder only models. They are focusing on generating the output. Understanding the input is fine because we are giving the tokens, right? But here, focus is more on generating the output. Okay, fine. Now, whenever we talk about encoder and decoder, see this. Always, whenever you are giving input to the encoder, what you do first of all? Embedding. One more thing you focus on is positional encoding. This is how the diagram is in the original paper. Understand this. You are giving embedding. What we understand, what is embedding? Second, positional encoding. If I say Virat Kohli is an excellent batter. This is at first position, this is at second position, this is at third position, this is at fourth position, this is at fifth position, this is at sixth position. We need to understand this, right? Which is at what position? So for that, we do positional encoding, right? To understand position of a token in an input. Okay, to understand position of a token in an input. Fine. Again, multi-head attention is nothing but self-attention. You have self-attention, one word focusing on each and every word. Multi-head attention, this word, this word, this word, this word, this focusing on this word focusing on this word focusing on this word focusing on this, like this. Multi-head attention. Okay. Okay. The same thing goes into, okay. Okay. The same thing goes here. Now see this output, and we are giving it to decoder. Output has shifted, right? We talked about mask encoding. Positional encoding is there. Output embedding we did. And here we're talking about mask and multi-head attention. Fine. And we talk about the feed forward value, feed forward network. There's linear activation function, there's softmax activation function, output probability, which word will come next. All these things are given in that. Now see this transformer, what is it doing? If there is mask word, dash was barking a lot. You'll give it to transformer, it will do embedding. Okay, this much is this much, this is this, this is this, this is that, this is that, and it will give the prediction layer. It will predict that it was a dog. The dog was barking a lot, like this. Now encoder. What encoder does? It understands input. Okay, so for example, when we talk about encoder input, 360DigiTMG is training is awesome. 360DigiTMG is the institute that I'm teaching here. Now 360DigiTMG training is awesome. Each and every word will be converted into embedding. Positional encoding, we say 360DigiTMG is first, training second, etc. Which one is the first, which one is the second? Basically, it tells the word position. Multi-head attention, model focus on relationships between one word, how important one word is with another word. Fine. This is what happens in encoder, in transformer. Next, again, it is addition and normalization layer. Addition adds the original input. We talked about it. Residual collection. Normalization normalizes the input. Basically, feed forward. Feed forward, if there's any complex relation, it learns that. Again, it's in a normalization. There's decoder model. Decoder model, again, this positional encoding is done, output embedding, positional encoding. We'll give some output here. We'll start with token like token with S before word, and it will give mask attention. Mask multi-head attention we talk about. What is mask multi-head attention? Mask multi-head attention, the last word is not known. Other than that, each and every word is known to us, right? Here, for example, when talk about this 360DigiTMG training is, now this will be the gap. It will give amazing as an output. Fine. Okay. Multi-head attention, again, addition normalization. Here you get the input here from the encoder. This is called encoder decoder block. Okay. Now, when we're talking about variants, this we have seen, always we talk about transformers are of three types. Transformers have different variants. It can be encoder decoder model, so we call it transformer. It can be decoder only model. This is a transformer 2. The T represents transformer, but T represents transformer. So when we say GPT, chat GPT, when we talk about chat GPT, GPT is nothing but generative pre-trained transformer. See this, it's a decoder only model. Now you understand what's a decoder, right? It takes masked input, and then after that, of course, normalization and everything is done. Decoder only model. When we talk about BERT is encoder only model. Encoder only means, see, there are two types of model when we talk about these things, right? See, encoder only model are not generative model, or are not considered generative model. Now, encoder only basically are considered discriminative model. discriminative. Are considered discriminative models. So if the model doesn't have a decoder when we talk about, decoder generates what? Decoder generates the output probability, right? Decoder generates the output here. This means when we talk about decoder only model and encoder decoder model, these two models are the generative models in true sense. These two models are generative models. So understand one thing, whenever you have this option of choosing which one is the generative model, understand one thing, that decoder only model and encoder decoder only model are generative models. Encoder only model is BERT. There is transformer, for example, encoder decoder model. Here we are talking about BART. We are talking about T5. These are two models. This is GPT, a BART, for example, or for example, DeepSeek, you say. That is also here in decoder only model. Llama, for example, from Facebook is decoder only model. Okay. Encoder only model, BERT. Bidirectional encoder representation from transformers. Okay. Now, these are the basic things we have. I'll go back again to this slides. Now this slide is clear. Now it will make more sense to have this particular slide. Now see this. Now when you understand this, now you understand what are these models. See, we are talking about text data till now. Okay. So when we talk about large language models, that can be encoder model, that can be decoder model, that can be encoder decoder model. Example of encoder model are BERT, Roberta, Distilbert. T5, encoder decoder, T5, BART, FLN T5, M5, MT5, ProfitNet. Most famous is T5 here, or BART. Decoder, GPT, GPT-3, GPT-4, Llama. In ChatGPT is nothing but this GPT model, generative pre-trained transformer, right? Now, when it makes sense, now see this. When we are talking about now, where are we actually focusing? We are focusing only on this blue thing. What is the blue thing here? This blue is nothing but the decoder only model. So when we talk about GPT, when we talk about Llama, for example, DeepSeek, V3, and again Llama, DeepSeek 2.5, Gamma, all these things, we are not even focusing on them much. We are focusing only on decoder only model, because these things are in true sense from the generative AI model, the model that we are seeing that are used in the large language models. These are the large language models we are talking about. Okay. Now there are autoencoders. Now autoencoders is past now. Honestly speaking, autoencoders, nothing much. You give the original input, you have encoder, they just what happens? This encode or whatever you give input is compressed, and there is decoder. It just reconstructs that input. Nothing much. They are constructed generative models because it was reconstructing input. It was giving some generation, nothing else. Right. So there is input, there are encoder models, there are decoder. Now when we talk about this autoencoder, there is encoder, there is decoder. It just shrinks it. It just takes the same from the compressed representation, or it just encoder just compresses the input, decoder just enhances it back. Okay, these are nothing but Now, autoencoder uses an encoder to compress an input into representation, and a decoder constructs the input from the representation. As we discussed, output from the encoder will be representation. Right. Now, we have discussed these things. Okay. So now you have any, now whatever question you have, feel free to ask team. Now we'll be moving further because this was very important for you to understand what are encoder only model, decoder only model. Now decoder only model, for example, application we talk about. What will be the application? This generation, text generation, and all those things for research and all. Encoder only. Encoder only, for example, basically these are discriminative models. Discriminative models means what? They're not generating anything. They are just saying, okay, this one is this one is this. Sentiment analysis, for example, to classify positive sentiment and negative sentiments. What is it doing? Classifying. This is positive, this is negative. In this way, you can use encoder only model. Encoder decoder model that generates something. For example, if you have to do text summarization, you already have a text, you want to summarize that text summarization, again it uses encoder decoder model, right? You should have this much of understanding. For example, just basic search on Google, for example, if you say encoder only model, encoder model or encoder only model here, it will clearly tell you, for example, birth, right? Focus on that. For example, text classification is particular we talk about classification, text classification. If particular word, for example, a particular email is a spam or a ham, is a spam email or a proper email, then that would be a classification. And sentiment analysis. Sentiment analysis means what? If, for example, there is comment, if there is positive sentiment or negative sentiment, but it's not generating something, it's not giving you the answer, right? So that is sentiment analysis. So for these things, encoder only model are used. So for example, if we talk about decoder only model, simple decoder only model. In a similar way, decoder only model, text completion. Text completion, why? Because it gives some output, right? Conversational AI. For example, chat GPT we talked about. We have a conversation, right? So conversational AI using chat, like chat GPT they have. Language modeling, okay, time text completion, all these things. Focus is specifically on output generation. Now, there are encoder decoder model too. I'll show you this too. Encoder decoder models. For example, this. Now, sequence of mostly for sequence to sequence task. As we said, text summarization. I give you an example of text summarization, like right machine translation. Image captioning, you have an image, based on that you have to caption that. You use what? You use encoder decoder model, right? For example, you use bird, that is encoder decoder model. Okay, fine. Okay, is this in clear, team? Different models we are talking about: encoder, decoder. Okay, online, is it clear, team? Let's talk about friends on YouTube. Online here, friends, is it clear for you what are encoder, decoder, and all those models? Or waveform? Okay. Okay, friends. Anyway, we'll be posting it at the end. Encoder decoder model, Sabrina, the same thing that we saw right now, right? It takes the input, gives the output. Now we have very less time, honestly. That's the reason, again, in very much detail I didn't go. It takes proper 4-5 days to understand the same thing, right? So, okay. Okay. Om Namah Shivaya, explaining it will take a lot of time again. See, there's a problem, right? Explaining encoder decoder model, yes, I can explain. Encoder only model, why is it used? Encoder only model is used for discriminative purpose, like sequence to encoder only model, right? Text, sentiment analysis, right? Machine translation. Here, for example, we are talking about encoder decoder model. It will be useful for what? Encoder decoder model for text summarization. Now encoder decoder only model for generation, right? How does the latent space in generative models encode meaningful features of data? Again, see, in Solid, it's already trained on that much of data. Again, the same thing happens. Whenever we talk about it, similarity search will happen, right? So again, that's the same use of it. Okay, now let's go back. Okay, these parts are very, very clear. Now let's come back to something called prompt engineering. Let's move to prompt engineering, friends. Okay, so choose has. When search on Google is decoder only. Yes, sir. Yes, Shahjan. Exactly. That something we generated that was decoder only. Okay, Joseph. Okay, team. Let's continue with the discussion. Now, prompt engineering is very important. Don't just think that prompt engineering when we talk about only whatever we write in ChatGPT. That's it. That's it. Prompt engineering. No, not like that. You have to structure things properly, right? When we talk about prompt engineering here, for example, if I go to ChatGPT, now whatever I'm writing in ChatGPT, for example, what is generative AI? This is a prompt. Sorry, my spelling is wrong here. Generative spelling wrong is wrong. Okay, when we talk about the same thing, this is what you gave was prompt. Now there are different prompting techniques, friends. There is zero shot prompting, there's few shot prompting, there's chain of thought prompting, there is again iterative prompting, right? There are a lot of prompting here, prompting techniques, right? Okay. Now, in this way, how to write a proper prompt or why prompt engineering is very important. In fact, let's talk about prompt engineer jobs. A prompt engineer's salary. How much salary prompt engineers get? 4.93, 85, 87.5 lakhs. Okay. Top roles can earn towards upwards of 30 lakhs, right? Now, senior level 20 to 30 lakhs. Depending on the company you are going for, it pays a lot, right? Why would people actually pay? Will they just pay you to just write anything? Of course not. When we talk about these tokens, see, whenever we're talking about tokens or you give some input, for example, I'm writing what is generative AI. Generative AI. Now understand here how many tokens are there? 1, 2, 3, 4. Each and every token costs. It costs something. So it is very much important for you to understand how to make a proper token, of how to make a proper prompt. Why? If the prompt is proper, it will give the proper answer. For example, now how to make a proper prompt or what are the elements of a proper prompt? When we talk about the elements of proper prompt, here, these things you need to remember. Always, whenever you are researching, please focus on these things: role, instruction, input data, context, rules, output format, examples, all those things. First of all, you need to give role. For example, you want to see the movie rating and all, right? Now for that, you will say, act as a movie critic for a popular website. Okay. And then you'll give some instruction. What do you need to do? If you are a movie critic, if the prompt is acting as or the generative AI or the LLM is acting as a movie critic, what we ask it to do? We ask it to create a blog post titled this. Task to perform, instruction is very clear. Then you give the input. Input data means what? Some information that you will give to support it. For example, list of 10 movies. It will give you list of 10 movies, right? And background is what? Context. What is background? Based on IMDb user rating. Now, you'll add constraints. This is called rules or constraints. Now, constraint is very simple. Constraints will say, do not include any spoiler article, right? You're clearly saying you're setting the boundary. Do not include this, do not include that. And we say, let's give output format. How do you want an output? Like a code snippet. And if you want to give example, you can give example. Let us type a perfect prompt, or let us type a really good prompt. Now you also try to type it T. Now you want to write an article, or for example, if some of you are professors here or some of you are teachers here, you might be understanding or you might be wanting to know how to increase the attention span of students in your session. So what will we do? We'll ask ChatGPT to work in that way, right? For example, we'll say, act as a famous professor. Okay, act as a famous professor. And what do we do? What do we want? Or let's give some input. Or what is the context? Act as a famous professor. And give me, what do we want first? Give me the method for increasing, or act as a famous professor teaching the other junior teachers about the method to increase attention span of students. Now, even more context you can give. The students are in university. The students are in university, or these are university students. Or here, we clearly say these are university students. Now, we need to give some context of some constraints. Constraints means what? We can clearly say, give me within this many number of words. For example, what happens is if ChatGPT gives a very big answer, you may clearly say that, okay, no, I don't want this type of answer. Or you won't even read. And that's the reason right now, nowadays, if you see in ChatGPT, there's one, at last it comes TLDR. Too long, didn't read. And it gives a summarization. So when we are saying these are university students, give the answer in 200 words. This is the limitation that we have set, right? The output should be in, how do you want the output to be? You want output to be in paragraph, you want the output to be points, right? Or you should be in bullet points. Okay, let's just make it bullet points. Now see this. Here, if you check, we talked about role, we talked about what to perform, right? We gave input data supporting information that students are university students, and context also we gave the same thing. We gave the constraint. Constraints means what? Up to 200 words you have to include. You have to answer in 200 words. Output format, how the output should be. The output should be in bullet points. This is how you write a proper prompt. Now, the answer that we get from ChatGPT is really, really good. We can ask Saurabh, that is also another thing. But if someone is starting, this is very important for you to understand what are the roles we should assign and all those things. We can clearly give ChatGPT the same thing. And isn't it like, okay, ask ChatGPT to what to ask and then get answer. A lazy method, right? Again, if you have a lot of things, then that's a different scenario altogether. You can ask ChatGPT to act as a really good world-class prompter and get the prompt too. That will be fine. Okay, so like this. But now, this is one method. There are different software. For example, there's Perfect Prompt and all those things, which will make your prompt a really, really good prompt. Right. Now, see this. Now let's focus back. Okay. Now, prompt engineering, there are direct instructions, open-ended prompts, Socratic prompts. Again, is it true or not? System prompts, if you are a helpful assistant. Other prompts. Now there are different type of prompts, friends. Direct instructions, we say, hello, how are you? Just one, see, we call this such things as zero-shot prompting. Zero-shot prompting, right? When you give one example to the same. For example, if I say, hello in Hindi means something, what other word means, like this. So here, direct instructions, open-ended prompts, Socratic principles. In this way, you can go for it. There's zero-shot prompting, there's one-shot prompting, chain of thought prompting, one after another, you're giving some prompts, right? These are chain of thought prompting and all those things. There are different prompts available. Now, there are some prompt tools as we discussed. You can clearly use these prompt tools to come up with your own prompts and come up with really, really good prompts. For example, Prompt Engine by Microsoft, right? Codified reusable prompt in code, right? And again, prompt generator, prompt GPT, prompt generator from ChatGPT itself, right? Again, there are different methods in this way. Now, understand that whenever we talk about output from a GPT, whenever you are making a model using large language model, we always give some parameters. These parameters are something that you should definitely remember when you are making really good applications. Now, for example, there's something called temperature. Temperature controls creativity. This means generally if it's 0 to, I mean, it is 0 to more than 1, that's fine. But if it's 0, if we say temperature is 0, this means it would be least creative. Least creative. But it will be most accurate. it will be most accurate. What it means, for example, if I say 2 plus 2, I clearly want a really accurate answer as 4. I don't want it to be creative. Yes, 2 plus 2 or 2 on 2, if you say you can make it 20 to 2. No, I don't want all those things. I want a proper 2 plus 2 answer. And that's when I have kept temperature 0. If I kept temperature as 1, that means it will be creative. Okay, so higher is the one, it is more diverse, it is less accurate. Lower is focused and deterministic, it will give you the proper answer. Now, top P, we say whatever top tokens you have, take those top tokens and set the probability, right? Until the probability is reached. Okay, you take some top tokens and you give it, you continue giving answer until you reach to a particular probability that this answer is reached. Okay, this answer is perfect type of thing. So again, we talk about diversity and relevance. We will balance both of these. Top K. What are the most likely tokens that we'll use per step, right? If we say smaller k values, that will be better. For example, if I say, if I have given 20 tokens as input, right? And if I say use all the 20 tokens at once, it may happen that because of these 20 tokens, it may diverge the answer here and there. But what if we want better answer? So rather than 20, we'll say take some 10 tokens or take some 5 tokens, right? Only top 5 token you take per step for each and every step. Okay. Max tokens. Max tokens will give you how long the response should be, or how big the response should be. For example, 500 words response, or the answer should be maybe in 500 words or 100 words or 200 words, like this, right? Now, longer sequence, increase cost. Now understand one thing, we'll be talking about this cost and all. So longer sentence, increase cost means just that more the words, more will be the token used, more will be the tokens, more cost it will have. We'll talk about the same thing when we talk about OpenAI and DeepSeek cost. Presence penalty, we say just try to explore new topics, right? Rather than reusing the last seen word, any seen word, just try to explore more words. Frequency penalty, if you're repeating again and again, it will be penalizing it, so that you give more different words rather than giving same answer again and again. Number of output, right? How much responses you want per prompt? Once you give one prompt, how many responses do you want? You want more prompt or you want more responses? It will be costly. If you want less prompts, it will be less costly. Best of. When we talk about best of, for example, model itself will generate multiple outputs and it will give the best output with highest token level confidence. Based on the token level, whatever question you have asked, it will return the best output. These are some of the things that we see when we are making model. Now there are different models. For example, chain of thought. Chain of thought means what? We are just going for one, next, and now next. After that, in this way, we say step by step. For example, you have 3 apples and buy 2 more. Let's solve this step by step. So what will you do? First step, start with 3 apples, buy 2 more, add them. Like this, each and every step it will give. If you have to go for stepwise answer, right, go for that. Zero shot prompting, just write whatever, translate the word hello into Malayalam. So it will just give the word hello itself. Again, auto COT, auto chain of thought, automatically it will be giving the same. We don't have to write COT examples here. Prompt engineering, we already talked about this, self-consistency and all those things. Right? React, there are something called React prompt and perplexity and all those things. Okay. Now, this was prompt engineering, a small, very small topic, just a basic introduction to you that there are some other the different elements. There are some other prompts that you can actually take your time and actually go and search for the same, right? So just if you note down this or you take a screenshot of this page, that will be really helpful for you to do your research further too. Okay. Okay. Now, this is what we are seeing till now. Now let's take break after this and we'll talk about other generative AI models. I'll give you an overview because we need to focus on LangChain and all those things. Those are more important. Okay, we'll talk about fine tuning. We'll talk about LangChain. We have to make a model and deploy it to that is our aim, right? So let's talk about all these models, different models we have in an overview. We'll talk about making Hugging Face token. We'll use ChatGPT itself to come up with the answer. Okay, or we'll use ChatGPT itself to make a new model or make an application. Okay, team. Is there any question? Is it clear till now? Whatever we have discussed? Let's ask our friends from YouTube.
Sir, will the notes be present in the website?
In the website, no, in the website notes is not present. Right, we'll need to talk to the backend team and they'll be informing you regarding the same. Once you fill the Google form or just mail us, that will be fine too.
Okay, sir. So where will we get the Google form?
Which one?
The Google form.
Google form I'll be posting. Don't worry about that.
Okay, sir.
Okay,
Thank you,
for
sir.
attendance and all that. Thank you. Okay, so we'll need to go here in this class. Now, so even ChatGPT does the text summarization, even though it's a generative model. Yeah. See, Derkio, it will do. Even though we are saying it's a text, again, ChatGPT generally, when we talk about GPT, we didn't say that it's a text it's a other model too. I mean, it's a, what to call it? Again, it does multimodal tasks too, right? Again, it uses those different way of doing the things, right? It gives summarization. It's just that the basic classification that you need to understand, right? For example, when you are making some model, for example, if you are making text summarizer, an app, if you have this understanding that text summarizer uses T5 or BART, for example, encoder decoder model, it will be really useful. It's not like it can't do that. If you give something, give some word, it will definitely convert that word, right? It has the capability now. But the basic is that it is used for what? It is used for GPT when we talk about. Generally, it's used for output generation. Text summarization, even it can do sequence. Right now, if you see, it can do a lot of things. It can do even this machine translation and everything. Translation, it can do. Summarization, it can do. So it's not like you can't go for anything. Just I'm talking about GPT, that if GPT is there, this is the task that it specifically does. In better way, in fact, I should say. Okay. I hope it's clear, Dekio. Yeah. Okay, notes are there. Okay. Can we get the notes? The same thing that whatever I'm discussing, right? See, there's no specific note. The only slide I'm referring, the same thing is there. AI tools for law. Anthony, I'll need to search. Honestly, I'm not from law background, but for example, there's something called Notebook LM, right? You can use that to make short notes. There's something called N8N nowadays, N8N. So you can use that too, right? What's prompt engineering, Shruti? Just the way of writing prompts we saw, right? That is prompt engineering. Okay. Okay, team, let's take a break for 10 minutes. In fact, 15 minutes will take, and then we'll continue and continue with the same. Okay, team. Let me just go back again. Yeah. Okay, team. Hi, I hope you guys are back. Let's continue with the discussion. So now let's talk about LangChain. So we talked about overview of generative AI. We talked about the basics, that is text mining, whatever text mining is required, tokenization, embedding, in all those things. We talked about different vector databases. We talked about vector databases, what is similarity search. We talked about the journey from RNN to transformers. Also, when we talk about transformers, we talked about different models. For example, talked about discriminative and generative models. What's the difference? Also, when we talk about we talked about encoder only model, encoder decoder, decoder only model, right? And we have seen prompt engineering part. Of course, all this is an overview. Prompt engineering was an overview, but now let's discuss about some other models that we have here. Now we have 1.5 hour, 1 hour, 1.5 hour we have. Let's just try to utilize this time to the max. Something's not that important, we'll just try to skip it. Not skip it per se, but I'll give just an overview of it. We won't skip anything. Now, for example, when we talk about image data, whenever we talk about this models, so for image, till now we are talking about text. For image, we know there was something called GAN, Generative Adversarial Network. Here, before diffusion models came into existence in 2014-15, we were talking about GANs, Generative Adversarial Networks. Now, how it used to work? Consider there is one painter, or where there is one painter, and there is one of his friend who is a really good discriminator. A discriminator who can actually tell if the particular painting is real or not. Right. Basically, or consider your teacher and you. Your teacher knows what a perfect answer looks like, right? And now, when the teacher knows what the perfect answer looks like, and you clearly have zero idea of it, then what you do? What you do? You try to write some answer, and teacher tells you, no, this is not the right answer, and teacher will say, okay, these are the points that you need to add. You will next time you'll come back again to the teacher, and teacher will say, okay, these are some points that you missed, you need to add again. And there will be, again, teacher will say the same thing, and you will again add those points. Or if you miss, go to the teacher, again teacher will tell, no, these are the points you need to add. What is happening every single time? Every single time you are getting a better answer, you are going to the teacher, and teacher is saying, no, this is not a perfect answer, you need to add these things. Basically, based on that, based on your answer, he's giving feedback, and you are actually improving that answer. So what is happening here? Two parts. Your teacher is acting as a discriminator. Discriminator clearly identifies if something is right or wrong, right? Something is good or bad. At the very same time, for example, discriminator, when we talked about encoder only model, encoder only model are discriminator models or discriminative models. Here we have student, for example, student is acting as a generator. The same thing happens in GANs, generative adversarial networks. Now, what's happening? First of all, we train the discriminator on the training data set. We give all the information or all the images. For example, we are talking about image of Mona Lisa. A Mona Lisa. We're talking about image of Mona Lisa. Then what are we doing? Mona Lisa it became, okay. Mona Lisa. Now, what is happening here? Discriminator was perfectly trained using multiple images of Mona Lisa, the same image. Now, discriminator knows what Mona Lisa's image looks like. So what we do? Generator will have some random noise. Basically, random noise is what? Some information, not some data, basically. Some information. Based on that, it will generate one image. Consider it generates image of Mona Lisa. And that's a fake image, okay? So what will it do? What will it do? It will give the same thing to the discriminator. It will give this image of fake image of Mona Lisa to discriminator. Discriminator will compare the original image and the fake image. And then it will say, no, this is a fake image. And it will give some feedback, right? It will give some feedback. It will clearly tell if it's a real or fake. If it's real, fine. If it's fake, it will clearly give a feedback. Now, generator, based on that feedback, creates another image, another fake image. Again, it gives to discriminator. Again, discriminator tells if it's fake or real. Again, it will create one image. Again, if discriminator takes if it's fake or real. What will happen, or what is happening here? Every single time you are generating something, discriminator is clearly telling fake or if it's fake or if it's real. Basically, generator is actually improving every single time. So ultimately what happens? It generates an image of Mona Lisa that is really similar, or it's just exactly as a real one, that even the discriminator cannot differentiate. So it just says it is real. So basically what are we doing here? We are doing image generation. See, when we talk about generative model, whenever we talked about generative models, initially there were 3 generative models that people focused on: GAN, autoencoder, and transformers. These are the 3 generative models that form the basic of generative AI. Now, here, this was GAN, basically generator versus discriminator, we are saying. Here, we have training data, we train the generative models, we do sampling, random noise we see, we get the generated samples. Fine. Training data, you are given the training model, you give the one image, and it will just predict if the particular model is true or not. Right. Now, this is what it is doing. This is what happens in generative versus discriminative. Now, that was state of art GAN model, right? Generative adversarial network. So now, when we talk about diffusion models nowadays are the ones that we go for. GAN is a past now. We focus on diffusion model. Diffusion model are used for image and video generation. Okay. Now, diffusion models are quickly becoming the go-to choice for generative modeling practitioner, particularly for visual domains. Right? We talk about DALL-E 2, Imagine, and all those things. Any idea why is it called DALL-E? Then this is actually fun fact. Any idea what is this DALL-E? See, the name, when we talk about DALL-E, for example, let's search. This is a basically model that we use here. ChatGPT is DALL-E. Image generator by ChatGPT. Right. Here, DALL-E 2. Right. It will create an image. But what is this DALL-E? There is actually, this DALL-E name came from one famous painter, Salvador Dali, and another one That is the movie Wall-E. Have you seen the movie Wall-E? Salvador. You see, there's a very famous Spanish artist, Salvador Dali, and there's a movie Wall-E. So what happened? These people, the creators, combined these or both of these together, and they created something called Dolly. Dolly does what? It gives paintings, right? Or it actually gives the image as an output. That's just a fun fact, nothing else. Okay. Now diffusion models, again, there's encoder, decoder, and of course there's denoising that's done in the middle. Now, you should understand that nowadays, when we talk about image generation, we use diffusion models. Diffusion model. There is something called stable diffusion that we are using nowadays. Right. Again, diffusion model takes it from thermodynamics, basically the thermodynamics diffusion that we have. Whenever we talk about image, we can do image classification, captioning, image segmentation, and all those things. Again, fundamental of image, vectors versus raster image vector. You can't expand raster, you can expand. Resolution, how much is the resolution, quality, different file formats we have for image, all those things. Now, there's something called clip. Clip you can use for multimodals, right? For example, when we talk about here, if you see, there is text and image. You are giving both an input, both as input, right? So when we talk about clip, it is used for multimodal data. For example, you give image as an input and you will get the output as its caption, right? What this image is. This is what a clip model will do, constructive pre-training model, right? So now, after that, we talk about diffusion model. Of course, diffusion model initially started with just very basic denoising diffusion probabilistic models, right? Now, when we talk about, there is specifically, we are talking about stable diffusion. Remember this word. Stable diffusion is what we focus on. And even in Hugging Face, we search for stable diffusion. Okay. Now there are different text to video generation and all those things. Let's talk about, you clearly got the overview of it, text to video generation and all those things we have. Blip we have here, bootstrap language image pre-training, and text to video generation and text to audio and all those things. There are different model, friends. Generative AI model. There are, again, for example, when you talk about text to audio, or for this, for example, we have Whisper model. Whisper model, again, by OpenAI, right? So again, this uses CLAP, for example, contrastive language audio pre-training and all those things. Of course, there are a lot of things in generative AI when it comes to generative AI. Encoder models, we clearly know what encoder models are, what are decoder models, what are encoder decoder models. We have clearly seen all these things clearly, right? LLM future, we'll be talking about it later. Let's come back to something called LangChain, something that is very important. Now, whenever you're making a model, after this LangChain, I'll just give you an overview of fine tuning, what fine tuning means. And after that, we'll move to making model itself. Okay. I'll just give you an overview of LangChain, what happens in LangChain so that you understand. And let's make a RAG implementation. Let's do a proper RAG implementation using LangChain. Okay. We'll see how we actually make Hugging Face models and all. So what is LangChain? Whenever we talk about LangChain is nothing but a framework that is used to make an application using large language model, or application that uses large language model. It's a framework. I should say open source framework. Anyone can use it. It's an open source framework. What it does, it just helps developers to make applications, or GenAI applications, you can say, or applications powered by or I should just say, why do I do for extra this thing? Make GenAI applications. When I say GenAI application, of course, using LLMs, SLMs, etc. LLM or SLMs, or SLM is nothing but LLM, large language model, SLM, small language model, right? Again, you can make a chatbot, RAGs, on all those things. Now, let's talk about important features that we have in LangChain. LangChain, whenever we talk about, there are some key features that you should remember. Key features. For example, when we talk about LangChain, there's something called document loader. Or I should say, I should clear this first. I should start with chains. There's something called chains that is very important, right? For combining models and tools in a sequence. There's something called chains. There's something called agents. Agents does what? It basically decides what tools to use. There's something called memory. Memory to retain context. When we talk about ChatGPT, it has memory, right? So you need to make sure you have memory. There's something called tools. Again, tools which can be used by agents. Now, there's something called retrieval or prompt template. Here, for example, we talk about prompt templates, basic prompt templates, nothing else. Templates or prompts. Now, there are many. There is retriever, and there is for example, you can say there's LangSmith, and there's retrieval, for example. Okay, retrieval also, right? That is fine too. There's retrieval, right? Retrieval for okay, bringing external knowledge using you can say data VDBs, vector databases. Okay, VDBs, vector databases. Now there are different such tools. We'll be seeing all these things. Now there are vector databases and all those things. Let's use LangChain. Now LangChain, you understand, basically a framework that will use to make generative AI application. How we'll make it? Let's see after this. Now, LangChain, you got the overview. There's something called LangChain, and there are different components that we use generally, right? We'll be talking about the chain. Now, let's make okay. After that, let me tell you about one more thing, something called fine-tuning. RAG we have already discussed, something called fine-tuning. And what is the basic difference between RAG and fine-tuning? Now, you clearly know When we talk about model, it is trained on large data set, right? Trained on large data or gigantic data or gigantic data, you can say, fine. But tell me one thing, if for example, we talk about model, it is trained on large data. Okay, fine. It is trained on a lot of data, fine. It is trained on massive data, fine. But at the very same time, is it trained on all the data that is available in the world? Doesn't happen that way, right? It is trained on specific data, that is fine, and that's massive data, and that is clearly fine. But a model is not perfect. It is not trained on all the data that is available in the world. This means for specific implementation, we may need to retune the model now or retrain the model. For example, if we talk about any model, even though it's trained on large data, it is not perfect. It is not trained on all the data. So large data, yes, but not on all the data. Right. Now, it may happen that you have to train the model again for your use case. Right. Now, you may want to, now you might have some data on which you want to train the model so that the model performs perfectly every single time. Now, fine-tuning is just a method of tuning the model, tuning or training the model, or I should say large language model or small language model. SLM, etc. Basically, BERT and also BERT and all you can clearly train. Now, what do you think? Then what would be the difference between RAG and fine tuning? What would be the difference between RAG and fine tuning then? See, when we talk about RAG, retrieval augmented generation, we are using external source. We are using external source or external document to support the LLM or large language model, right? For retrieval. Here we are not making changes to the model. Understand this. This is very important to understand, a very basic difference between RAG. Exactly, Farin. When we are talking about RAG, we are just giving a supplement to the model. We are not making changes to the model. We are not tuning the model. But when we talk about fine tuning, we are actually retraining the model. Not on complete data, on the limited new data. So what are you doing here basically? You are retraining the model for that amount of data. For example, if your large language model already knows information that is For example, 90%. That is 90% information it already knows. You are doing what now? You want to use this capacity as well as you want to make this large language model even more efficient. So what you do, for example, you have 2% of new data. That is large language model not tuned on. So what do? You fine tune. Now the question would be, why is it required to fine tune the data, fine tune the model itself? For our requirement, simply for our requirement. Now, is it possible to fine tune every model? Yes, it is possible to fine tune. I shouldn't say every, it is possible, but again, just to be more having middle ground, just to be in middle ground, I'll say most of the model. Now, can you fine tune ChatGPT or GPT model? No, for that, they have some security for feature. They won't let you train the model. Right, but there are some models, for example, BERT, that you can clearly train on some image data set. For example, I've tried this previously. I've done one of the project in that. Yes, exactly, Joshep. When we are talking about RAG, it's just giving external sources. It is just fine tuning, is just tuning the model. Exactly, model retrieval. Basically, the answer then will be from model itself rather than adding external data. Right. This is fine tuning. Okay. Now, once you understood fine tuning, let's come back to this part, and now you'll be able to understand this particular slide in a really, really good way. Is that yes? Now see this. Now, when you want a proper answer, you have large language models, right? And you are getting content from the model, or you are getting answer or the output from the model. You're getting the output from the model. And you're talking about large language model. How do you make large language model? How do you optimize the content or make the content better? You use RAG, right? You use prompt engineering. That is fine. If you use prompt engineering, you will be getting better answer. But when you use RAG, you'll be getting specific answer. But at the very same time, that large language model itself is not optimized for your need. You are just adding external data source or external data. But when we are talking about fine tuning, what are you doing to the large language model? You are tuning the large language model itself, right? So here, what are we doing? Optimizing the LLM. Fine tuning, when we are just improving or making the large language model better. So now see this particular portion where you have the most optimized LLM and you have the best content optimization too. This territory, basically, if you have a large language model and you are fine tuning that model, and you are using RAG also, don't you think that model will give the best optimized answer possible as per your demand? Right? It will give, right? Exactly. So this is what it is doing now. So this is what we are doing when we are talking about fine tuning and RAG. We are just improving the process to get the best answer possible, the best content possible. Okay, so this is one way of doing things. Now see this. Now it will make much more sense. When we talk about foundational model, prompt engineering, of course, we have foundational model, we use prompt, we get the result. Evaluation, that we'll see, we use Rogue and Blue score to evaluate the same. Now, improvement loop. If you evaluate the result, if the result is good, fine, deploy the model to the production, right? And then you will be monitoring and evaluation, that will be fine. But if the result you evaluate result, after that you want to go for improvement over the model, or you want to enhance the answer, or you want to optimize the answer. What you do? You go for RAG. Okay, so you go for add extra knowledge, you add RAG here, and then you evaluate. Of course, you can fine tune the model for particular task too. For example, you want summarize, you want to do summarization. You can fine tune the model for summarization, or you can fine tune the model for again sentiment analysis, right? But you can clearly do that. Classification and all, right? For classification, you can clearly tune the model. For a particular task, you can tune the model, giving more data or all these things like that. Now, improvement, how to improve it? If you are having RAG and fine tuning both for a specific task, you can train a large language model and you get the better answer. You deploy the same to the production. Okay. And when we talk about evaluation, when you make the model, you go for what? You evaluate the model. We evaluate using ROG score, ROG and BLEU. These are the two scores that we use. I'll just Google it because I don't have slide here. I'll just write ROGUE, ROG, or Rouge, you call it, and BLEU. These are two things, BLEU, two things that we use to evaluate the model. For example, you can just go here and just search for ROUGE and BLEU score. Right, for NLP evaluation. When talk about this, you can clearly read about that. When talk about Rouge and BLEU, both are used for large language models. For example, RAG evaluation metrics, how good the score is, right? Rouge again calculates recall value. BLEU calculates precision. Right now, what is evaluation? What is precision and what is recall? You can please search for it. Okay. Two commonly used metrics for evaluating the quality of text generated by an NLP model. Now, that is, now you understood RAG, right? Now, when we are talking about RAG, now there is one more advancement over RAG, and that is multimodal RAG. Multimodal RAG. Just write these words, and after this session, please search for all these things. Just because of paucity of time, multimodal RAG. I'm just wanting to multimodal RAG. I just want to give you the most things possible. Multimodal RAG, when we're talking about, you can just search for multimodal RAG. What is multimodal RAG? Harness the power of both textual and visual information. Right, you get the better answer for multimodal RAG using multimodal RAG. What is the difference between RAG and multimodal RAG? RAG works with only text data. Multimodal RAG working with text as well as different formats. Right. Now, understand these things. RAG, multimodal RAG. What is multimodal model? Multimodal model working with more than one model. Right. More than one modality. Modality basically maybe text, maybe videos. When we're talking about multimodal model, it's working on more than one. Right. Just be clear with your concept like this. Okay. Just try to connect each and every dot. Just be really good at that. Okay, fine. Let's move towards the next topic. Okay. We'll move towards, now we'll try to make a RAG application, right, using ChatGPT itself. Okay. Do you guys know how to use Streamlit? Okay, I'll do one thing. I'll explain the same thing here in this session itself, and we'll try to make a better one. Okay. For example, let me just quote this. Okay, let me make a RAG model itself. Here, how to do that? You can come to the YouTube side, this session again, and you can clearly do that again. Okay, fine. Okay, do you guys know how to work with Streamlit? Streamlit, STREAMLIT, deployment. Okay, no, fine, no worries. There's something called Streamlit. Okay. Now see, we have covered most of the portion that you need to understand to get the base of generative AI in today's session. Now let's nail it ultimately by making a Gen AI model that you can use here in the session itself. Or you can try to make your own generative AI model. How do you do it? Let's try to make it. First of all, what is Streamlit? Is Streamlit needed always? No. You can use Fast API. You can use other things too. But when we are talking about this, Streamlit is what we use to deploy the model for deployment. Okay. It is very easy. Don't worry, it's very easy. You can try right now in your system too. Okay. First of all, if you are thorough with Visual Code, fine. If not, you can go for any other tool. You can use Anaconda distribution, and you can use Spider too. I'll be using Visual Studio Code. First of all, try to understand. Again, we are for projects that we do here, we'll code a lot of things, but right now we are not using any other thing here. Right? We are just using ChatGPT just to show you that this is how things can be done. Okay. Now let me make a folder here. New folder. I'll make, for example, I'll just make folder ASAP. Okay, because of ASAP, we are here. Now, I'll just start a VS. I'll just start VS Code. Within short time, we'll try to make it. Okay. If you are thorough with VS Code, good. If not, use any Python IDE. I'm completely fine with that. This is basically. Open new window itself. Fine. Now, when we're talking about VS Code, how do we use VS Code? First of all, you made a folder outside, right? Rather, here also you can make a new folder, but that's fine, not needed. Right now, we'll just open a folder. Okay, we'll open a folder. Which folder? It's in C. So we'll see C. We'll go here. ASAP is the name of a folder. Fine. We'll select the folder. Right. Now, once you select the folder, you are in the folder itself. You have to make sure that you are using terminal. The really good thing about using VS Code that you can use terminal. Now there's control tilde below your escape button. There is some sign called tilde. So control tilde, use it, and you will open a terminal. Right. Just a minute. There's some questions. Siri. Siri, I'm not searched for that, honestly. Honestly, I have not searched for agents for VS Code. Right now, I'm just focusing on making these things. You can just simply Google that. That will be fine. Okay. 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 So first of all, when we are talking about this, let's make a basic thing. Whenever we are starting a new project, we need to create a new environment. How to create a new environment? You can just say Python MVENV, and I'll just make it as ASAP. Okay, then I'm just making a new environment here. Okay, ASAP, fine. Now we want to use this environment. So ASAP, if you are having Windows, just say, oops, sorry. This is scripts and activate. We are doing what? We are activating the environment. Yes, before we go there, let me take you to Hugging Face. Just search for Hugging Face. Now, Hugging Face is one platform where you have a lot of free models, right? All the models we talk about here in Hugging Face are free. If you go to the models section, there are a lot of models, right? For example, whichever model you want to use, any application, for example, if I see text generation, image to text, if you talk about image to text, you'll get a lot of models here for image to text itself. If you want to go for any other thing, text generation, for example, for text generation, you will get another model, lot of models here, right? So there are different models present. Okay, fine. I'll remove this. I'm just taking all the models. Now, one thing is very important whenever you are working with Hugging Face, they may ask for, or you may need to get the token. Hugging Face token is very important to access some of the models itself. For example, passcode, it's asking, I'm not sure if I'm logging using this. Okay. In. Okay, fine. Here, I had made a new one token when I was delivering a lecture on generative AI in Coimbatore or in KPR College Coimbatore. Okay, fine. Let me create a new token. How to create a new token? Where do we go first of all? Whenever we open Hugging Face, in Hugging Face, you can just come here, right here. You can just see access tokens. Access tokens, you can create a new token. Whenever you create a new token, remember, go to read and token name. For example, I'll just say ASAP Gen. Yeah. Okay, fine. I'm just creating a token. Now remember, tokens are very important. You should not share your token with anyone just because I'm not using this. I won't be using token anywhere else. I'm just okay with typing, keeping the same. For now, I'll just keep this token here. Okay, this is my token. Now it may need to, we may need to make env file. Fine, if we make env file, that will be fine. If not, right now we're not focusing on that. Let's focus on, I just wanted to show you what is Hugging Face and what are different models. Fine. Now, let me go to ChatGPT here. And let me create, first of all, let me create a new file here. I'm just creating a new file in Windows, in VS Code. For example, I say app.py. Fine. I'm making app.py. First of all, we need to install Streamlit. So I'll just say pip install Streamlit. Right. Now, when we are using the Streamlit's latest version, nowadays there is an issue. Sometimes it gives issue. So you can just use the previous version. 1.24 or 1.35 is really good stable version. I'm using 1.24. First of all, let's see how Streamlit works. let it install. It is installing. Okay, wait, that's not an issue. You can start using VS Code too, friends. That's completely fine. Let it install. Okay. It's just then saying the pip version is expired. So we'll just upgrade the pip version. Python, oh, not Python -m pip install upgrade pip. Okay, fine. It's upgrading the pip. Okay, fine. Now it is successfully installing. Okay. First of all, if you want to use Streamlit, just try to experiment with it. st.title. Okay. First of all, we need to import Streamlit, right? So import. Whenever you are using Python, you need to install import the libraries, right? Invoke the libraries. Streamlit as st. st, we are aliasing it. Now let's move further. We say st.title. Here already it came. I'll just give st.title. I'll give first line. First, for example, if I want you to show how Streamlit actually works, whatever changes we'll make here, that will be represented there, or that will be that's something that will be changing there. Okay, that the same thing can be seen there. Okay, so we'll say hello. This is my first. Okay, fine. I'll make this. I'll say do Control S. I'm saving it. Okay. Now, what will I do? I'll first of all run this. I'll just say Streamlit run app.py. Just use tab so that it goes to the proper file. Now, since we have just used Streamlit, nothing else. See this. We'll get, hello, this is my first Streamlit app. What happened? Directly from VS Code, you deployed it to the website. This is in your, not website per se, but this is in your own system, local host, right? Hello, this is my first Streamlit app. So now, whatever change I'll make here, for example, I'll just say st dot write. Okay, st dot write, file write. For example, if I just write quotation marks, hello world. Okay, if I just write hello world, now see this, Control S, and the same thing will be displayed here, but it's not displaying. So what we will do? Always rerun. See this, st.write hello world. It again came here, right? Hello world, you can clearly see. Now you clearly know what is happening. We are just running the Streamlit app and it's showing on the browser. Now we want to make a Streamlit app for doing RAG implementation. Fine. Let's go to ChatGPT directly. We have very less time. If not, I would have coded and shown it to you completely. Now, I want to make, okay, act as an best program, or best Gen AI developer, and give me a Streamlit app. Give me a RAG app. Yep. RAG using Streamlit. Give me a RAG app using Streamlit. Best Gen AI developer and give me a RAG app using Streamlit. And also Streamlit. Oh, you can use Hugging Face. I have its key with me. Okay, now what we'll say, act as a best Gen AI developer and give me RAG app using Streamlit. You can use Hugging Face. I have its key with me. Also, give me the dependencies. Sorry, give me the that should fit. Okay. RAG app using Streamlit. Okay, fine. Now it is giving RAG app. Is it using LangChain? No, we'll say use LangChain. Okay, we'll just edit it since we know we have use LangChain. Use LangChain, so it will use LangChain now. Since we already know we have used LangChain, right? Now, in LangChain, we talked about vector databases. So we have vector store. These are the components: vector store, embeddings, we have LMs, we have document loaders, we have text splitter, we have chains. Now there are many. We have seen some components. Now these are other components too. Now see this. Whenever you have to create an env file. How to create an env file? Go to VS Code, for example. I'll just add one more file. I'll write .env. env. What do we do with env file? We have the tokens here. So whenever you will use env file, whenever it will ask for your Hugging Face token, just give your Hugging Face token here in env file. Please don't share your tokens with anyone else. Right. Now, first of all, let me go back to VS Code and I'll give the code. Now, env file is ready. Right. And you have app file too. It is just giving this query completely. Now, you can just copy paste it, but I'll just explain what is happening here. Or I'll just copy paste it and then I'll explain what is happening here. You clearly know what is the path that we are using for RAG. Okay, we are making app.py, just clear everything because we are using Streamlit directly here. Streamlit app directly here. Now what is happening? Here, 10-15 minutes, it should be ready. See, .env to load that env file. Now we have LangChain. We saw there's something called LangChain. It's open framework that we use to make the generative AI applications. This is what we are doing right now, making the generative AI application. Vector store, embedding, large language models, document loader, text splitter, chain. All these libraries we are in LangChain library, we are using these modules, and in that these functions. When we talk about FAISS, what is FAISS, friends? Remember, we talked about vector database, Facebook AI similarity search, right? For embeddings, we have to do embeddings. Remember, for embeddings, we are using Hugging Face embeddings. For large language models, we are using Hugging Face Hub, right? We'll see what models we are using here. Okay. First of all, you are loading the environment EVN file, ENV file, right? What are you doing here? You are taking the token. Take token from where? From ENV file, Hugging Face API token. We have clearly copied. Now, when we are talking about set_page_config, we are giving the page title. Now you can give layout, that is wide. Again, there are other things that you can give. Title, we are just saying ask questions on your PDF using RAG, right? Now we are giving one option to upload the file. In Streamlit, you have the option to give a file. So you can use in Streamlit, there's something called file uploader. You're using the file, and we want what? We want PDF. Okay, we want PDF. Now it just says here, there will be spinner. Spinner will do what? Like this, it will go round. It will just say reading and splitting your PDF. Fine. And we are saying, we are just saying that part temporarily. First of all, load PDF and split. Remember, what do? We have data or COPS. That COPS, we do what? We do tokenization. And we tokenization, or that is splitting, we do text splitting. Text splitting is nothing but tokenization. Chunk size, how big each and every token should be. Chunk overlap, how the overlap should be. More is the overlap, better is the retrieval. Text splitter, we are splitting the document, whatever we got. Next, once tokenization is done, we are using embedding here. Now see this, embeddings, we are using Hugging Face embeddings. What are we doing? We are just saying embeddings and storing it where? Storing this embeddings in the vector database, in the vector store. Once this is done, we have stored in the vector store itself. We are saying from Hugging Face 1, use this model. We are using FLAN T5 large. FLAN T5 is again one model that we are using here. We talked about temperature. Temperature is 0.5. 0.5 means what? If you say 0, 0 is least creative or more deterministic. When we talk about 1, or we talk about higher the temperature, more will be the creativity and less perfect answer, less deterministic answer. We are saying 0.5, that we are okay with a bit of creativity. Maximum length 512. The token, the output token that will generate will be of 512 words, 512 tokens. Okay. Now once that is done, what are we doing here? We are having a chain. Remember LangChain, when we talked about chain is one of the very important component of LangChain. So we say retrieval QA that from chain types. We are basically making a chain. LLM, we are using LLM. Which LLM you are using? You are using FLAN T5 large. Retriever, the retriever that we are talking about. From where will you from where we will retrieve? Will retrieve from the vector store. What is vector store? FAISS, Facebook AI similarity search, right? From document, we'll make embedding. For document and embedding, both will take. Okay. Now retrieval is done. We'll get the success, right? Now that is for the internal part using the large language model. Now we'll need to give the input to input, ask a question from document. We'll ask question from the document itself. What it will do? It will say answer QA.run. QA is what? The complete chain we talk about. The chain will function and will get the query. We'll get the query, it will run the query. And again, inside it, what will happen? The query will be broken down into chunks. Chunks will be embedded. The same thing will go to FAISS, basically the vector store. From vector store, we'll get the best answer possible. The prompts will be connecting, will be giving it to the model, and it will generate the answer. Let's not forget the process that we discussed from the very start. We are just trying to implement whatever we have discussed. Right now, here, will it run right now? No, it won't run. Why? Because we are not yet installed the dependencies that are required, or we are not yet installed the libraries. Now here, when we are talking about terminal, stop the terminal using Control C. Control C stops the terminal. Now what we need to do, of course, we can create a requirement file here, but right now, let's not create a requirement file. Rather than that, let's just go back. Okay. Okay. Now, there must be some requirement because we talk about the requirement, right? What we need to install. Copy this directly and paste it here. Don't worry, right now we don't have enough time. Copy and paste. Now there's something called LangChain, fine. FAISUU.NV, working face, fine. And there's something called LangChain community that's missing, that will give error. LangChain community that you need to have. It will give error if not. Oops, Streamlit, I again installed the latest version. Okay, it will take time, no worries. Till that time, let's go to YouTube. Okay, fine. Team, are you doing it with me? Please don't waste time. Start doing it. Let's not waste our time here. Let's continue making it. I just want to see what is in here. Add again. Okay. I can't see any question. Fine. Yes, one shot. Will be providing it. Don't worry. I'll be providing it. Once it's done, I'll be providing the same. Just give me 10-15 minutes. Okay. I just want to show you the RAG app, nothing else. Yes, Om Namah Shivaya. You can clearly do that. That's completely fine. But please, guys, write your name too, huh? Please. Okay, I'll close this. I'll provide a Google form here itself. I have it with me, friends. Don't worry. In fact, I'll do one thing. I'll just provide a Google form till that time. Okay, it's already ready. Now I'll just close it, install Streamlit again. I'll change the Streamlit version since the new version has some issue. Okay, it's already satisfied. Let's try Streamlit run. Streamlit run what? App.py, right? I hope you have saved this. Streamlit run app.py. Let's just run it and we'll encounter error. If you're encountering error, we'll just solve it. That's not an issue. Okay. Bravo. We are not encountering any error. Already, whatever error we have, since we have practice, we have clearly cleared that. LangChain community, it will throw error. If not Streamlit, it will throw error, all those things. Now let's give a PDF itself here. Now ask question on your PDF using RAG. Now let's browse file. If I have any PDF here, for example. Okay, now see this is saying you install sentence in transformers. Again, this is not give errors. Control C, Control C here. Control B, install sentence transformers. Till that time, I'll just I'm just stopping screen share, friends, for some time. I just want to, this is my own personal WhatsApp here. I'll be giving you, it's already 4:30, right? Just okay. Okay. I'm posting here the chat as well as Google form I'll post. Okay, in chat, friends, I'm posting one link. You can fill that form here and your attendance will be marked. Okay, you got the link. Now I'll just go to YouTube for our friends. Right, I'll just go there. Again, the ad, same ad. Okay. I'm posting the chat itself, team. Please see this. Okay, I can't post it over. No worries, I'll just post it. Okay, I want to post it. I'm not able to post in the chat here. Okay, guys, someone of you, if you have access, please post it here too in the YouTube. Basically, I'm not able to comment, it seems. Okay, join the chat. I can't open the panel here right now. Fine. No worries, friends. You have this online. Please post it. You just copy it and just please help me in this. Just post it in the chat box itself in YouTube. Okay, if my team is here, let me just check if my team is here. I don't see my team. Okay, in YouTube that may not be possible. Just give me a minute. I'll open my own session. I will go there. We'll have to log in. I'm already logged in, Bhagya. Okay, no worries. Guys, any one of you, please, I request you to go there on YouTube and please post it so that we can use this. We can clearly go further. Or I'll use my personal. Yeah, thank you, Fareen. Yeah, let me just post this on YouTube using my own personal ID. Okay. Just a minute, team. Okay, team, my team will be posting the Google form here, right? No worries about that. Yeah, 360DigiTMG, you can see There's a Google form available, right? Don't worry about that. Please put your attendance there, right? Okay, thanks, Fareen. Thank you so much for that. Actually, I missed that. Okay, no worries. Our team has posted the same, right? Thank you so much, and let's continue. Right, I'm just here. Let's just continue with this rack thing. Now, let's try to Streamlit again. Streamlit run. Let's see if you are facing any error or if it's running properly. Okay, drag and drop, browse file. For example, if I just say anything, for example, machine setup error. Now it's reading and splitting the PDF. See, it's reading and splitting the PDF. We already talked about the same. Right, let it do that. Whew. Yeah, just a minute. Till the time is going on, just give me a minute. Now, team C, we have made the document. It is done. And we are talking about what is the document all about? What is this document all about? Right. Enter. Now, what it did, I gave the output input. Yes, Sebastian. Oops. I'm getting attribute error. Inference Cloud has no worries. I just post it in chat with itself directly now. Don't have enough time. We'll use Falcon 7 then rather than this. We use Falcon 7 rather than FNT T5. Okay. We are using Falcon 7 now. Again, rerun, browse the file. Let's search for some file here. It will take time this time, so, friends. It will take time to run. Ask question. What is this document about? Let's see if we are getting the answer now. Or we are still getting the error. That's fine. Error and all is part of the answer. Okay, still we don't have the still we are facing this error. No worries. Inference object has no attribute post. In that case, okay. It's not supporting that model, like it's fine. Or we can just use a different model here. For example, if we are T5 base, Control Z rather than T5 large, we can try with T5 small, right? Small, we can try with small, that will be fine. This is a new model, different model, right? So no worries, see, this will be part and parcel of the game. That's not an issue. This is how things will be. Again, we're facing the same issue. or we'll ask for the complete code. Give me a complete code itself, right? Fine. Just ask for complete code. Set up API key, everything is done. That's the same thing. Whatever we have discussed, it's the same thing. It's just that the final there are some errors, nothing else. We don't have enough time to clear the error itself, but it will be cleared. That's not an issue. Okay, fine. Just rerun that. Browse file. What is this document about? Okay, we're still facing this error, but no worries. You clearly know how to clear that. You can just go back again. It may take more time, right? So now there's one or two concepts that we need to discuss. We'll just talk about it in brief since we don't have a lot of time, but you understood now how to make app by yourself if you have to make it. 2-3 concepts. Just we are wrapping up the session. First, hallucination. When we are talking about model, large language models sometimes don't give proper answer. That is nothing but hallucination. Okay? Hallucination means the model is not giving the desired answer or what should be answered. For example, sometimes you may type your name. Since the model is not trained in your name, it may hallucinate. Or even if the model is trained in your name, it may not give proper answer because it might not be trained on complete data, right? So that is one thing. Now, the last thing we talk about today, and we'll finish the session, friends. You can just work on the large language model and try to work with RAG and all those things. Okay, let me just go for the last topic that we talk about. This, the future of large language model. Now understand, large language model actually has ethical problem, right? If it's not trained on the data that is proper, there can be bias in the data. For example, if it's trained on only data that a particular country is really good, but at the very same time, the country might have some problem. But the large language model won't show because it is not trained on that data. In the similar way, it may be trained on some ethnicity. Again, it may not be telling you about other ethnicity properly just because the same data is available online. Now, when we talk about current state and future directions of large language models, again, there is explainability and transparency that is actually needed. Understand one thing, that when we are talking about explainability and transparency, whenever you are working on any project, clients demand explainability and transparency. When we talk about AI models, those are black box in nature, right? We talked about that. For improving the trust or enhancing the trust, we need to make sure that our model is explainable and transparent. Nowadays, more research is going on towards multimodality rather than just being stuck at particular mode, right? Rather than being stuck at one modality, we're talking about multimodality. Lifelong learning, of course. All the time, the model is learning. We need to make sure, not just you, the model that is learning in the background, and that's the reason we are having GPT-4, GPT 4.5. What is happening? It's getting trained on even more data, right? Now, ethical and societal impact, we talked about human AI collaboration. Now, when we talk about human AI collaboration, it just helps to enhance human capabilities, right? And promote partnership where humans and AI can work together. We need to see in that way. Also, right now, there are no regulatory bodies. We need to come up with regulatory bodies. So there are no regulatory bodies in the world that can actually control all these models, right? So we need again, there are intercontinental or there are some talks going on amongst the countries and in the groups that we should come up with these models and all. So talking about vision for the future, LLMs will become invaluable tools, understanding human language and augmenting human efforts across various domains. So friends, this is it from my side. LLMs are really good. Large language models, generative AI models are really good. So since morning, we covered the basics of text mining, that is what is tokenization, embedding, all those things, what are databases, all those things, right? We talked about the complete journey, right? From RNN to transformers. We talked about different transformers we have. We talked about prompt engineering, how to write a perfect prompt. We talked about other generative AI models. Of course, I gave you an overview of other generative models that are there. We talked about LangChain. We saw what is RAG, what is fine tuning. We saw the difference between RAG and fine tuning. We talked about how to make your own model and deploy it. Of course, there are some errors that are coming, but and I explained each and every step. What are we doing there? So, and we talk about the large language model future to what are the biases that we have, what are the ethical considerations we have. So this is it from my side, team. This is it from our side. This is 6 hours of session, completely packed with a lot of information. I hope you enjoyed this session, and let's connect some other day. And yes, we'll be learning a lot more. Yes, and when I said research about something, please go and research about the same. Right? I believe you'll come back really very strong. And thank you so much, team. Thank you so much for your time. And I guess I have here. Yeah, thank you so much, Joseph. I hope it's clear for all of you, right? And thank you for being so active, Joseph and friends, for Farheen and all those. And friends, yes, Malvika, yes, Joshua. Joshua will be getting certificate soon, right? No worries. Thank you, Joseph. Thank you so much, Farheen. Thank you so much. Definitely, Farheen. Please go for it. Right. Yeah. Thank you, Alexander. Thank you, Shajan. Let me just call my backend team so that they can just come and finish the wrap up the session. Right. Now, thank you, Sania. Thank you, Fida. Yeah. Thank you, Jason. Yeah. Thank you, Preeti. Yeah. Yeah. Hi, Miss Vinny. You there?
Yes, sir.
Yeah. Hi, Miss
Can we
Vinny.
conclude this section?
Yeah, we can conclude the session, ma'am.
Okay.
And yeah, there are some chats that I just need to respond to them. Yeah, thank you, Sriyari. Thank you, Nan. And
Okay. Good evening, everyone. On behalf of ASAP Kerala, thank you all for joining today's SmartLearn sections on generative AI. A special thanks to Mr. Bubedra for delivering an insightful and energizing sections. Your clarity and energy truly made an impact. Thank you. To all participants, your energy and the active involvement brought great value. We hope this section inspired to explore emerging technologies further. We look forward to see you in this next SmartLearn section. Until then, stay inspired, stay skilled, and keep learning. Okay, please fill up the Google form given in the WhatsApp group for the certification. Thank you. Thank you so much.
yeah, thank you, ma'am. Thank you so much for your team, for your cooperation team. And please keep rocking. All the very best for your future, right? Please take care and enjoy your time, team. Take care. Bye. Bye, guys. You can see there are a lot of chats again, but yes, this is it from my side. Thank you so much for your time, team. Maria, Matthew, Naomi, Dia, Joshi. Yeah, LB basically. Yeah, thank you so much for your time, team. Take care, guys. Bye. Good night.